Bueno, buenas tardes a todos. Soy Marina Sender, la presidenta del Colegio Territorial de Arquitectos de Valencia, y os quiero dar la bienvenida a nuestra sede, con motivo además de unas conferencias internacionales Rafael Guastavino, enmarcadas en el tercer Seminario Internacional de Bóvedas Tabicadas, que está organizado por el Máster Universitario en Conservación del Patrimonio, con la Escuela de Arquitectura. En primer lugar, quiero agradecer, primero, que hayan contado con el colegio para celebrar estas jornadas. Segundo, a Ernesto Fenollosa, que nos acompaña también en esta presentación. A Marta Alonso, directora general de Patrimonio Cultural de la Generalitat Valenciana. Y, por supuesto, a Santiago Tormo, como director del máster, que está aquí también en la mesa. Y a Camila y a Fernando, que son amigos, compañeros y que siempre cuentan con el colegio para casi todo. Realmente poco más. Yo creo que la importancia del seminario y de las jornadas sois vosotros casi más conocedores que nosotros. Siempre estos seminarios tienen una repercusión importantísima y para nosotros como arquitectos en el Colegio de Arquitectos de Valencia, todo aquello que tenga que ver con arquitectura, con patrimonio y que esté relacionado además con la ciudad de Valencia nos parece importantísimo celebrar y destacar. Además, no sé si sabéis que nosotros tenemos un espacio cultural en la planta baja que precisamente toma el nombre de Guastavino, de Rafael Guastavino. Poco más tengo que deciros, aparte de daros la bienvenida y de desearos también que si tenéis un minutito veáis y visitéis la exposición que tenemos en planta baja, que precisamente habla de los 35 años del Gulliver, del Parque Gulliver, que está en el río de nuestra ciudad. Así que poco más. Muchas gracias a todos por venir y paso la palabra a Ernesto Fenollosa. No, tienes que darle a la tecla.
Aquí. Vale. Bueno, buenas tardes a todos. Directora General de Patrimonio Cultural, Marta Alonso, presidenta del Colegio Territorial de Arquitectos, Marina Sender, director académico del Máster de Conservación del Patrimonio Arquitectónico, autoridades, ponentes, compañeros todos, estudiantes que asistís a este seminario. Bueno, yo decir un par de detalles además muy de flash. Lo primero, reconocer y agradecer la capacidad de los organizadores de este evento, Camila Mileto, que la tengo por aquí, y Fernando Vegas. La capacidad de organización es algo que nos desborda a todos. Igual están organizando un congreso de patrimonio, como están reeditando libros sobre la conservación y la rehabilitación, como están invitados en China a participar en una conferencia. O sea, es tutti frutti a lo cual es casi imposible llegar. Así que lo primero es reconocerlo. Agradecer, por supuesto, a la Generalitat, que patrocina estos actos, es contar siempre con ellos, no solo a efecto de patrocinio, sino a efecto de apoyo. El estar aquí con nosotros presentando este acto pone en valor la importancia del seminario que se está organizando. Y luego al colegio, porque pienso que es tremendamente importante la colaboración entre las tres instituciones, entre la Generalitat, que lo acabo de nombrar, el Colegio de Arquitectos, que representa a la profesión, y la Escuela de Arquitectura representando a la academia. De hecho, pues aquí en la sala pues congregamos a los distintos colectivos y es algo tremendamente satisfactorio que tanto los estudiantes del máster en patrimonio, fundamentalmente, que ahora ya estén tocando, que estén aquí en el colegio tocando la profesión, como que después pues otros profesionales arquitectos vendrán, nos acompañarán también en la Escuela de Arquitectura. Así que agradecer la presencia a todos y desear que este seminario pues sea muy fructífero y que aprendamos todos mucho. Así que bienvenidos, bienvenidas.
Gracias. Buenas tardes a todos. saludar a Marina Sender, presidenta del Colegio Territorial de Arquitectos de Valencia, Ernesto Fenollosa, director de la Escuela Técnica Superior de Arquitectura de Valencia, Santiago Tormo, director del Máster de Conservación Arquitectónica, Camila Mileto y Fernando Vegas, catedráticos de la Universidad Politécnica de Valencia. Y a todos ustedes, arquitectos, futuros arquitectos, enamorados de la arquitectura. Es un placer, estoy encantada de participar en este seminario, en este tercer seminario internacional. Estábamos comentando, quería felicitar en primer lugar, porque lo hemos comentado fuera del micrófono, pero felicitar públicamente porque creo que soy historiadora del arte, pero tengo una profunda admiración por la arquitectura. He seguido el trabajo de Camila y de Fernando desde hace años y me parece que en este trabajo, por ejemplo, no solamente de sus proyectos, sino también de haber diseñado este programa de hoy, tan necesario en la reivindicación y el debate sobre las bóvedas tabicadas, felicitar públicamente por este magnífico programa. Estoy encantada de participar hoy aquí en este seminario internacional y también en esta sede, porque hace unos meses tuvimos la ocasión a raíz de la Dana, y me van a permitir que haga ese breve paréntesis porque estuvimos aquí presentando el plan de inspecciones de la Dana y quiero agradecer públicamente al Colegio de Arquitectos una vez más. Lo hemos agradecido infinito porque ante el reto que tuvimos como sociedad y que seguimos teniendo, el Colegio de Arquitectos, en especial el Territorial de Valencia, estuvo desde el minuto 1 apoyándonos en esa gran desafío, y me gustaría brevemente comentar que gracias a esa labor tanto del Colegio de Arquitectos como también de la Universidad Politécnica, del Máster, de muchísimos profesionales de la Politécnica que se brindaron a ayudarnos de manera voluntaria y desinteresada, conseguimos hacer ese plan de inspecciones que nos permitió identificar los bienes más afectados, que sirvieron para empezar a programar intervenciones que pudimos hacer directamente desde la propia Dirección General de Patrimonio Cultural de la Generalitat Valenciana. Pudimos abordar las intervenciones de emergencia, las primeras intervenciones que nos sirvieron para acometer lo que era nuestro primer gran reto, salvar aquellos bienes de interés cultural. Pero además pudimos, gracias también al Colegio de Arquitectos y a la Politécnica, abordar también los bienes de relevancia local. Hoy puedo decir, porque me gustaría simplemente hacer balance, ya que quedamos hace unos meses en ese trabajo de inspección, informar públicamente también de que estamos y seguimos contando, por supuesto, con la voluntad que ellos siempre se están brindando a ayudarnos en el seguimiento de este tema de la Dana y los bienes afectados. La semana pasada se publicó un decreto Dana, que nos ha permitido, se ha diseñado especialmente porque nuestra gran ambición aquí, están acompañándome dos personas fundamentales de mi equipo, Olimpia Ferreiro, la subdirectora de Patrimonio, y Ignacio Matoses, Servicio de Arquitectura de Patrimonio de la Dirección General, porque les quiero también agradecer públicamente porque han estado desde el minuto 1 ayudándonos, haciendo un equipo para hacer posible esa labor de inspección y al mismo tiempo de programar estas primeras intervenciones. Y quería explicar públicamente también que ahora mismo estamos en el reto. Hoy mismo, esta mañana, hemos tenido una reunión con la idea de seguir salvando patrimonio afectado por la Dana con este decreto Dana en el que ya se han presentado, tenemos 25 bienes y afortunadamente hay bienes afectados en los que teníamos ya identificados a través de las inspecciones y vamos a poder contribuir a los bienes que identificamos, bienes de interés cultural y BRLs más afectados, poder salvarlos gracias a este decreto de ayudas. Y simplemente quería poner al día esta información porque quizás a algunos puede ser de interés. Creo, como ha dicho Fernando, este es un apoyo que también venimos brindando desde hace tiempo y que estamos muy satisfechos porque creo que es muy enriquecedor para las dos instituciones, que seguir colaborando en este máster universitario de conservación del patrimonio en la Universidad Politécnica de Valencia a través de esta ayuda y que permite, como ha dicho Fernando, la realización de actividades formativas y prácticas curriculares de los estudiantes con actividades como las que se presentan hoy en este seminario internacional. Entonces, para nosotros también es una satisfacción poder apoyar eventos como este y apoyar también la formación de futuros arquitectos y la reflexión sobre qué queremos hacer con la arquitectura en la Comunidad Valenciana. Me gustaría hacer una reflexión porque para mí las bóvedas tabicadas, como historiadora del arte, para mí constituyen una de las grandes señas de identidad o símbolos de historia de la arquitectura en el antiguo Reino de Valencia y Comunidad Valenciana, uno de nuestros símbolos y referentes, y además creo que es uno de los elementos que creo que es lo que, por eso está así diseñado el programa, que bebemos de esa tradición de las bóvedas tabicadas, pero creo que, y eso es lo que plantea el programa, nos tiene que servir como reto de futuro también, bebiendo de esa tradición, plantearla como objeto de futuro. Recordar que la ciudad de Valencia se va a tratar más en profundidad lo que representan las bóvedas tabicadas, pero la ciudad de Valencia alberga uno de los patrimonios constructivos más ricos del ámbito mediterráneo, donde la técnica de la bóveda tabicada me permitirán que además apunte de las bóvedas valencianas, como siempre ha citado mi profesora catedrática Mercedes Gómez Ferrer y otros autores, bóveda valenciana, se van a abordar el por qué se llaman así a lo largo de este seminario, constituyen un legado material y cultural de extraordinario valor. Su empleo, extendido desde la Edad Media hasta bien entrado el siglo XX en edificios industriales, religiosos y domésticos, representa un ejemplo sobresaliente de la arquitectura tradicional adaptada al clima, los materiales locales y a la cultura constructiva valenciana. Sin embargo, pese a su relevancia histórica y su presencia en numerosos inmuebles catalogados, esta técnica sigue siendo poco conocida fuera de los ámbitos especializados y requiere una revalorización integral desde la investigación, la docencia y la práctica profesional. Esta es una de las razones por las que estamos ante este tercer seminario internacional. La organización de estas jornadas sobre bóvedas tabicadas en Valencia responde a la necesidad de revisar y difundir los conocimientos técnicos, históricos y patrimoniales asociados a este sistema constructivo, promoviendo el diálogo entre profesionales, investigadores, estudiantes y entidades públicas vinculadas a la conservación del patrimonio arquitectónico, en un contexto donde la sostenibilidad y la recuperación de técnicas tradicionales de bajo impacto adquieren creciente protagonismo. La bóveda tabicada se presenta además como un modelo paradigmático de eficiencia estructural, durabilidad y economía de medios, plenamente alineado con los valores contemporáneos de la arquitectura responsable y el uso racional de recursos. Estas jornadas pretenden también fomentar la transferencia de conocimiento entre el ámbito académico y la práctica profesional, abordando la bóveda tabicada desde perspectivas complementarias, su historia y evolución en la arquitectura valenciana, sus cualidades constructivas y mecánicas, los criterios actuales de restauración y conservación, así como su potencial contemporáneo en la arquitectura sostenible. De este modo, la iniciativa se plantea no solo como un espacio de divulgación, sino como un laboratorio de reflexión y experimentación que contribuya a la preservación activa de este patrimonio técnico y cultural. Asimismo, la iniciativa busca reivindicar la figura del arquitecto valenciano Rafael Guastavino. Hemos comentado también que creo que es un referente para todos nosotros y además nos sentimos muy orgullosos cuando hemos estado en Nueva York y alguien desconoce al gran Guastavino de acompañar personalmente y presentar, ¿no?, los grandes hitos que marcó en esa ciudad. Guastavino, formado en la tradición local, emigró a Estados Unidos, consiguió difundir internacionalmente la bóveda tabicada, bóveda valenciana, gracias a él y a todos los maestros del siglo de oro valenciano, a la que dotó de un nuevo reconocimiento técnico y artístico como referente de la creatividad arquitectónica valenciana. Su trayectoria ilustra cómo la sabiduría constructiva local puede convertirse en una herramienta de proyección global, anticipando conceptos contemporáneos como la prefabricación cerámica, la modularidad o la sostenibilidad estructural. Finalmente, este tercer seminario, organizado desde el Máster de Conservación del Patrimonio Arquitectónico de la Universidad Politécnica de Valencia, al que nos une una estrecha colaboración, sigue la trayectoria iniciada de los dos anteriores celebrados en los años 2011 y 2018, justificando la necesidad de preservar, documentar y difundir las bóvedas tabicadas existentes en el patrimonio edificado mundial, muchas de ellas aún sin catalogar ni valoradas en su justa medida. La presencia de ejemplos relevantes en el patrimonio civil y religioso, sumada a la tradición artesanal y al tejido académico vinculado a la Universidad Politécnica de Valencia, convierte a la ciudad de Valencia en el marco idóneo para articular un encuentro que combine la investigación científica, la formación especializada y la sensibilización patrimonial. Las bóvedas, como he dicho al principio, para mí constituyen estas bóvedas tabicadas un símbolo de orgullo de nuestra historia, un símbolo que tenemos que reivindicar, pero un símbolo útil para seguir marcando que la arquitectura valenciana sigue siendo un referente y sigue marcando una línea muy clara de progreso y de excelencia. Quiero acabar dándole la enhorabuena de nuevo y las gracias sinceras al Colegio de Arquitectos por su compromiso siempre con el patrimonio valenciano y de ser nuestros socios privilegiados en esta ardua y bonita y gratificante labor de contribuir a dejar un patrimonio mejor entre todos. Quiero también felicitar, como siempre, por supuesto, a la Escuela Superior de Arquitectura de Valencia, a la Universidad Politécnica y al Máster Universitario de Conservación del Patrimonio Arquitectónico, por mantener siempre estos niveles de excelencia que son un orgullo para todos, por su ambición para seguir formando a los mejores profesionales en la arquitectura y en el patrimonio. Para los que estamos trabajando desde la administración pública, creemos, y lo hemos comentado muchas veces en el equipo, es tan importante que haya profesionales excelentes haciendo proyectos que sean referente. Entonces, gracias y enhorabuena, porque es importante que se formen los mejores profesionales en la gestión y en la promoción del patrimonio. Y gracias por aportar con seminarios y como eventos como este la necesaria de aportar, además de la formación de los futuros profesionales, aportar tanto en la necesaria reflexión académica, tanto para la arquitectura como para el patrimonio cultural valenciano. Muchas gracias.
Muchas gracias, Marta. Muchas gracias, Ernesto. Muchas gracias, Marina. Muchas gracias a todos, participantes, ponentes. Donde se comparte conocimiento, se construye la arquitectura. Quería empezar con esta frase, que no está atribuida a nadie, pero que resume en esencia la idea de nuestro trabajo, tanto en la escuela como en el Máster de Conservación del Patrimonio Arquitectónico. Un máster que este año celebra la 20ª edición y que además lo celebra con el premio que le ha otorgado el Consejo Social como el mejor máster de la UPV. 20 años precedidos de otros 17 como título propio, que le convierten en uno de los másters más antiguos a nivel nacional y por el que han pasado casi 700 estudiantes. Una iniciativa que nació de la propia Consellería de Cultura, allá por los años 1986, con las competencias transferidas en cultura para poder tener un cuerpo de profesionales y técnicos formados desde las especialidades de gestión y de intervención, para intervenir sobre el patrimonio arquitectónico. Un máster que siempre tiene presente la necesidad de ampliar conocimientos en todos los ámbitos, pero especialmente en el de las técnicas constructivas que hoy nos reúne aquí, capaces de formar esos vínculos necesarios entre la tradición y la modernidad, como lo hicieron el E.T.S, Antoni Gaudí y Rafael Guastavino, entre otros. Un Rafael Guastavino que saldrá en muchas ocasiones en este seminario y que representa la síntesis entre el artesano y el visionario. Un creador que llevó la sabiduría constructiva valenciana a la escala del sueño americano. Su vida demuestra que la sabiduría del oficio se convierte en grandeza cuando se une el coraje de emprender y aprender. Y por eso estamos aquí, para aprender una vez más, y con este ya son 3 seminarios internacionales celebrados en el máster, para motivarnos con infinidad de ejemplos construidos en todo el mundo y que nos permiten visionar el alcance tan tecnológico, tan innovador, tan sostenible, tan nuestro, que representa la técnica constructiva de la bóveda tabicada. Una verdadera creación que surge de comprender profundamente la tradición. Esa lección de economía estructural, máxima resistencia con mínima materia, y que establece un diálogo entre gravedad, equilibrio y fuerza. Un seminario que se organiza desde 3 asignaturas del propio máster: Teoría e Historia de la Conservación, cuya responsable es Camila Mileto; Estudios Previos 2, cuyo profesor responsable es Luis Cortés; y Criterios de la Intervención, cuyo profesor responsable es Fernando Vegas, y que comparten espacio y sabiduría en el oficio. Quería agradecer enormemente a la Dirección General de Patrimonio, y la miro, y en especial a su directora Marta Alonso, que sin su ayuda, no solo económica, estamos cada día defendiendo la salvaguarda de nuestro patrimonio, es nuestro objetivo común. A los colegios profesionales, por supuestísimo, Marina, el Colegio de Arquitectos, también al de Arquitectos Técnicos, que también participa en este seminario, y a la cátedra EMR, CPA, que gracias a ella y a la empresa EMR, aquí tenemos presente a Inés Cámara, Merce Ortí creo que está en streaming, y también a Alejandro Mir, el maestro de obra que ahora en estos momentos se encuentra ejecutando una bóveda tabicada que vamos a ver estos días allí, directamente en la universidad. Pues gracias a ellos pues, podremos observar lo que es la construcción de esta bóveda. Y esa bóveda al final, como nuestra esencia de valencianos, que tenemos una gran fiesta en la que quemamos todo, pues también no la vamos a quemar, la vamos a demoler. La vamos a demoler desde un punto de vista riguroso y académico, en el que poder ver todos esos estados tensionales que sufre antes de la caída, para poder analizar estructuralmente cómo funciona una bóveda tabicada. Ese es un poco el rigor de esa prueba, de esa experiencia. Y las últimas palabras las dedico a Camila y a Fernando. Como no, excelentes profesionales, excelentes profesores y excelentes personas. Incansables en todos los retos que se proponen y que en esta edición se han superado. Han organizado, yo pienso que una programación inigualable, muy diversa, que nos va a permitir ampliar ese conocimiento de esta técnica constructiva tan singular y tan desconocida. Ya sé que no están todos y que faltan algunos, pero los más de 30 profesionales y profesores van a demostrar que la bóveda tabicada es una forma de pensar, una forma de construir con menos para durar más. Muchas gracias. Y ahora tenía que subir Fernando y Camila.
Bueno, pues buenas tardes. Y bueno, queríamos estar los cuatro en la mesa, porque bueno, entre los cuatro hemos organizado todo esto y con el apoyo de todos los que se han ido nombrando. Entonces era fundamental estar los cuatro porque creo que es un trabajo de todos. Entonces, bueno, pues yo antes de todo, obviamente, dar las gracias pues a Marina Sender, obviamente, la presidenta del Colegio Territorial de Valencia, que nos hospeda hoy y que nos ha brindado esta ocasión de trabajar juntos. Ernesto Fenollosa, el director de la Escuela Superior de Arquitectura, que siempre nos brinda su ayuda y su apoyo. A Marta Alonso, la directora general de Patrimonio Cultural, que también nos brinda siempre su apoyo y su ayuda. Y bueno, por supuesto, a Santiago y a Lidia, que están aquí con nosotros, respectivamente director académico del máster y coordinadora académica del máster. También quería dar las gracias a los que no están en la mesa o que no han ido pasando por aquí. El Centro de Cooperación de la Universidad Politécnica de Valencia, que nos ha ayudado trayendo algunos de los ponentes, la Cátedra MR, por supuesto, que también nos brinda siempre su ayuda, y el Colegio de Arquitectura Técnica. Y dar las gracias a todos los ponentes, a los 37 ponentes que desfilarán en estos 4 días, que han hecho esfuerzos para hacer sitio en sus agendas súper apretadas y que han querido estar con nosotros en estos días. Y por supuesto a los asistentes, que la verdad que aparte que es fantástico ver una sala tan llena como la que tenemos esta tarde, hay muchísima gente también online, porque no cabíamos todos en la sala. Entonces, bueno, pues agradecer el interés, porque yo creo que es lo que realmente nos mueve, saber que estamos haciendo algo que interesa, que tiene vigencia, que mueve a la gente para estar con nosotros en estos días. Se trata del tercer simposio y creo que que es de justicia recordar los dos anteriores. El primero se organizó en 2011, como se ha dicho anteriormente, lo organizaron Arturo Zaragoza, Rafael Soler, que está aquí con nosotros y al que le tengo que agradecer esa primera organización, y a Rafael Marín. 7 años después se organizó el segundo, en 2018, organizado por Rafael Marín, Arturo Zaragoza y luego ya Fernando, Santiago y yo. Y 7 años después, parece que es como una cadencia necesaria, 7 años, pues ya estamos aquí otra vez con la organización de los 4 que veis en la mesa. Parece que 7 años es una cadencia muy amplia, pero quizás es necesaria para realmente tener novedades. O sea, las novedades en investigación, en proyectos, sabéis perfectamente todos que los proyectos de restauración muy rápidos no son, requieren tiempo, requieren estudio y por lo tanto, pues 7 años, aunque parezca mucho, pues es realmente un tiempo de ir madurando, ¿no? Con lo cual, yo creo que es bueno, que hay que pensar que 14 años después, respecto a la primer seminario, estamos aquí otra vez. Eso quiere decir que algo de interés sigue teniendo todo esto, porque 14 años después estamos aquí otra vez para hablar de investigación, hablar de intervención, restauración, conservación y hablar de innovación. Creo que son un poco los 3 pilares que nos unen a todos. El seguir investigando porque todos tenemos una pasión increíble hacia la bóveda tabicada y seguimos dándole vueltas y buscando lo que hay detrás, delante, de arriba y abajo. La conservación, que es fundamental y pasa también por la investigación. Si no sabemos lo que tenemos, tampoco lo podemos conservar, con lo cual es algo que siempre va de la mano. Y la innovación, que también es necesaria para saber más, necesaria para seguir conservando y para seguir manteniendo. Bueno, pues tendremos delante 4 días intensísimos, con muchísimas aportaciones, pero bueno, que pensamos que serán muy, muy provechosos. Esperamos que sean muy provechosos para todos. Y paso la palabra a Fernando para que vaya comentando el programa.
Aquí estoy. Bueno. Bien, pues nada, rápidamente para no comer tiempo a los conferenciantes. Yo recuerdo que hace 14 meses empezamos a organizar esto. Y contactamos con Tim, que está aquí sentado delante, y dice, venid a Nueva York, que hay un montón de novedades. Y dice, mira, no vamos a ir a poder a Nueva York. Estábamos cerca porque vivíamos en el momento en Los Ángeles, pero no podíamos ir. Dice, pero no te preocupes, que vas a venir a Valencia y lo cuentas todo tú. Bueno, vamos a ver. Entonces la estructura del seminario va por bloques, o lo hemos organizado por bloques. Hoy por la tarde estamos en esta casa y vamos a dar un homenaje digamos, a esa vigencia que tiene la obra de Guastavino, ¿vale? Padre e hijo. Mañana tenemos el bloque 2 hablando de la historia, de los precedentes y toda la historia que hay abundante. Luego pasaremos al bloque del modernismo, muy interesante porque vamos a ver por primera vez cosas que no se han visto antes, pues como la torre Bellesguard de Gaudí, todos los estudios que se han hecho recientemente, los estudios que ha hecho inéditos todavía de Domènech y Muntaner, restauraciones de la finca Güell de Gaudí. Bueno, yo creo que todo muy estimulante. Después pasaremos a otro bloque que hemos llamado Otras Bóvedas, ¿no? Para hablar de otro tipo de bóvedas. De hecho, ha empezado ese bloque, empieza con las bóvedas persas, donde hay de todo, literalmente de todo. O sea, podemos encontrar desde las bóvedas tabicadas a las bóvedas por hojas, etcétera. Lo vais a ver, es muy interesante. Y luego, pues, otro tipo de bóvedas, ¿no? Luego pasamos a geografías, lo hemos llamado así un poco poéticamente, porque había bóvedas tabicadas de muchas partes del mundo que van a ser muy interesante ver cómo efectivamente se trata de una técnica que se ha difundido mucho. Pasamos luego el viernes al bloque 6, antiguos y nuevos experimentos, donde ponemos experimentos con bóvedas, con tierra, con bambú, con bóvedas ligeras, con bóvedas tabicadas de piedra, porque hay bóvedas tabicadas de piedra. Otra cosa es que no sean autoportantes, pero son bóvedas tabicadas de piedra. Luego vamos a hablar también, vamos a tener un taller práctico de bóvedas tabicadas y por último vamos a tratar el tema de la estructura, la construcción y en el uso actual de las bóvedas, ¿no? Finalmente acabaremos con una conferencia, digamos, final sobre una de las obras más importantes de restauración que ha habido recientemente, que es la restauración de la estación de trenes de Detroit, ¿no? De Guastavino. Y el sábado tenemos una serie de unas visitas a varios edificios restaurados y nuevos con bóvedas tabicadas. Esto es todo.
Bueno, damos paso ya a las charlas, ¿vale? Y a las conferencias, con lo cual, bueno, damos paso a la primera. Se queda Fernando presentando. Bueno, muchas gracias a todos por estar aquí.
¿Cuál es su ordenador este?
No lo sé.
¿Cuál es? Bueno. Aquí está el botón. ¿Sí? ¿Me veis? Sí. Bueno, pues nada, vamos a arrancar y bueno, es todo un honor tener aquí para arrancar este seminario a José Luis González Moreno-Navarro, al cual yo no sé muy bien si presentar o no presentar, porque al final yo creo que es conocido de todo el mundo. Digamos, ha sido catedrático de construcción en la Universidad Politécnica de Cataluña, ha hecho realmente aportaciones y libros muy importantes que siguen siendo referencia actualmente y sobre todo también en torno a las técnicas constructivas y en particular a la bóveda tabicada. Y como él dice, además de ser arquitecto, catedrático, escritor y haber enseñado los misterios de la construcción histórica a centenares de alumnos, es guastavinista de la primera hornada. Y es cierto. Bien, pues nada, gracias por venir. José Luis.
Me queda un poco así como carrasposo, espera.
Bueno, espero.
Bueno,
yo te avisaré.
A mí se me oyó, ¿no? Porque es aquí.
Tienes que empezar aquí. Te avisaré con
Vale. Bien, es una responsabilidad ser el primero, ¿eh? Yo no había pasado nunca. Yo he estado aquí en el de hace 14 años, el de hace 7. Yo estaba en medio y siempre estar como más tranquilo, ya llegará y tal, pero esto de estar el primero obliga, ¿eh? Bueno. Yo voy a hacer una conferencia un poco diferente de las otras. No voy a hablar de la técnica tabicada. Voy a hablar de un hombre, de un señor que se llama Guastavino, que tuvo pues sus problemas, sus alegrías. No voy a entrar en nada dramático, pero no lo digo para que es diferente. La conferencia que voy a hacer es diferente, pero incluso diferente de las que yo he hecho toda mi vida. Entonces, fijaros, el Teatro, la Massa, tal. Aquí aparece la cúpula, que yo la aprecio mucho porque gracias a Rafael Soler la conozco a fondo, la famosa cúpula. Y después me ha hecho mucha gracia ver el Memorial First de Berkeley, que es una de las obras de Guastavino más raritas que he visto nunca, porque son todo cositas así. Y además en la quinta puñeta, que yo cuando estaba allí dije, pero ¿cómo trajo todos los albañiles de Nueva York, los trajo aquí para hacer esto? Es muy curioso, ¿eh? Bien, sigamos, espera, que no me equivoque al pasar, pim, pam, pum, que me vaya a... Esto como siempre es diferente, supongo que aquí voy bien. Bueno, entonces fijaros, el primer punto es algunas experiencias mías, personales, y una conclusión. Es decir, yo no explico mi vida, que voy a explicar lo más rápido posible, sino para llegar a una conclusión muy concreta, que es lo que organiza el resto de la conferencia. Y además voy a añadir, ya lo he añadido, un cierto camino de investigación hipotético, que también será al final. Bien, como veis, como modo de persona, de mi persona, con experiencias personales, la que tengo más cercana es la de hace ni un mes, que he ido a una conferencia en el teatro sobre las cúpulas de Guastavino en el Maresme, que es el sitio de Vilasar, y luego Manhattan. Esto me lo pidió un amigo, un compañero de la escuela, un catedrático de urbanismo, una cosa, y que habíamos comentado, habíamos participado en alguna cosa que salía Guastavino. Oye, tú sabes de Guastavino mucho, ¿por qué no organizas una conferencia y traigo a mis amigos? Esto me lo dijo más o menos antes del verano. Y digo, pues nada, pues un día fuimos hablando y entonces al final, ¿dónde hacemos? Pues vamos a hacerla en el teatro. Al final, si hablamos y hicimos y quedó muy bien, quedó muy bien, pero bueno, pues he aprendido mucho para hacerla. Y ahora para hacer esta todavía he aprendido más, porque es que se sabe muy poco de ella. Pero bueno, fijaros, esto es el Barcelonés y el Maresma, y ahí está Estamos muy cerquita todos. Y la sala de edad. Muy bien, este es el teatro, yo calculo que es 1900, no se sabe exactamente la fecha, pero por ahí, que es para que veáis, esta foto va a salir mucho, y lo que hace es presentar la foto que viene a continuación, que es esta. Este, como veis, vuelvo a ser yo, el otro día. Esto es la experiencia que, como veis, estoy explicando en la diapositiva, sale lo que os he dicho que explicaba, ya cuando al final y dije gracias por vuestra atención y todas estas cosas. Bien, pues ha sido una experiencia interesante hacer este esfuerzo y ahora ya empiezo, retrotraigo a el pasado lejanísimo, 1970. Ya, como veis mi cara, dijo, hostia, este soy yo. Me cuesta creérmelo a mí. Pues sí, estuve en Nueva York. Entonces, la experiencia no es de aquel momento, que evidentemente era una experiencia interesantísima, pero en relación con Guastavino, fue cuando con el tiempo, ya pasados 20 años, empecé a conocer obras de Guastavino. Un día me dije, pero ¿cómo estuvimos? Un grupo de arquitectos, éramos los 100 de la promoción, era el viaje a fin de carrera, en Nueva York, y nadie nos nombró Guastavino. Es muy fuerte, es que no se le conocía. En Cataluña, por supuesto, pero allí tampoco, porque el que lo descubrió fue George Collins, con el artículo este que habló de la pasa de la bóveda hacia el tabicado. Y claro, en Barcelona se siguió como, pongamos, 20 años sin conocerlo. Y yo no, yo tuve la suerte de participar como más o menos un arquitecto más o menos reconocido ya en aquella época, de que sabía algo de construcción, en las primeras visitas que se hicieron al teatro para ver qué era aquello. Porque es que, no, hay que, por suerte el ayuntamiento tomó la decisión de restaurarlo, llamó a la Diputación de Barcelona, la Generalitat no hizo ni caso, la Diputación sí, y yo a través de la Diputación fui y claro, ostras, vaya cúpula, hostia. Bueno, claro, ya estaban por allí Margarita y Busadé, que como sabéis son los factotums de las estructuras en aquella época y en Barcelona, y yo estuve calladito, dice, porque tampoco sabía tanto yo ahora sé mucho, pero hace todos estos años sabía menos, podéis comprender. Bien, esto fue muy interesante, pero ya me quedó en la memoria. Dice, ostras, pues sí, yo estuve allí, ¿qué pasa? Vale. Este es un caso también que es una demostración de la barbaridad que fue aquella época. Esta es la casa Julià de Guastavino, en Paseo de Gracia, que aquí ya no está, como veis. Y fijaros, milagro, crece. Patapón, crece un piso. Fue una salvajada de tal nivel que cuando la explico yo, lo más duro para mí es que yo estuve trabajando los 5 años, hasta 5 años antes, con los 2 arquitectos que la hicieron. Entonces, para mí es una sensación de rabia, primero porque se hiciera esta barbaridad, ¿no? Pero segundo, porque si yo hubiera estado trabajando allí, hubiera dirigido el desmontaje y habría hecho 1000 fotos, porque había bóvedas. Nadie hizo nada. No, es que los tiempos han cambiado mucho, como veis, menos mal, porque ostras. Bien, los años pasan, llegamos a los años 90 y en la Escuela de Arquitectura empezamos ya a movernos, empezaron a llegar, bueno, y salió los primeros libros que salieron desde allí y lo compramos y ostras, nos quedamos maravillados. Y entonces cuando yo me dije, qué barbaridad, si estuvimos en Nueva York y nadie nos dijo nada. Bueno, tampoco es que nadie sabía nada, ni allí tampoco, pero bueno. El caso es que va pasando el tiempo y ahora estoy más o menos recordando las cosas como han ido apareciendo. Esta la exposición que se hizo en Madrid, el libro de Santiago Huerta, después también los que aparecen, los que aparecen por aquí, para no repetir los nombres. Y este ya es cuando se hace la restauración que empezó a plantearse cuando yo estuve aquel año, en los años 80, que ya se ha restaurado y está realmente muy interesante. Entonces, yo sigo trabajando, yo sigo haciendo, bueno, eso ya es un poco después, ya me meto en Guastavino en serio, y fijaros, eso es las cosas más interesantes que hice, es eso que se llama el curset del Colegio de Arquitectos de Cataluña, que es una reunión que se hace cada mes de diciembre sobre temas, y este año yo lo cogí y me dije, vamos a hablar de bóvedas, tabicadas, y bóvedas de todo tipo. Y entonces uno de los temas fue la bóveda tabicada. A ver, arriba ya veis también es el libro que yo hice de bóvedas tabicadas con Huerta. Y después abajo, como veis aquí, aparece un rinconcito Ken Diebold. Hola, estás por aquí. ya llevamos ya, y fue interesante conectar con Nueva York, y lo pude hacer porque tenía una doctoranda que estaba haciendo una tesis sobre Guastavino, pero no prosperó. Lo que sí que me sirvió, porque además sabía inglés, claro, y era centroamericano. Y nos conectó con todos. Y eso fue muy fácil. Y esto fue un momento maravilloso, esta ocasión. Tanto que el Colegio de Arquitectos siempre organiza un viaje a partir de lo que se hace en aquella ocasión. Y naturalmente fuimos a Nueva York. Bueno, como visteis aquí la de la Columbia University, que aquí es donde George Collins, mirando la bóveda, dijo, hostia, ¿y esto de qué es? Y de ahí sale todo, como ya sabéis. Bueno, decimos Nueva York, bueno, lo que queráis de Nueva York, todo. Porque además nos llevó la Mark Loren, que es una especialista, hizo un libro sobre la bóveda, sobre todo los aspectos más urbanos, culturales de la ciudad. Y estuvimos aquí con Janet Parks, que nos estuvo enseñando ya veis, todo el archivo que tienen de planos, que es deslumbrante. Yo hice algunas fotos así, las tengo guardadas por ahí. Y bueno, me dediqué a viajar. Y entonces, fíjate, estos son todos los estados, que no las ciudades, porque serían muchas más, todos los estados en los que yo he estado viendo obras de Guastavino, entre otros, porque yo también yo iba viendo Guastavino y Wright, dos épocas del mundo y de la historia. Pero era un contraste, Dios, ves Guastavino, iba con mi mujer. Vamos a ver esa que es de Wright. Y claro, Guastavino podía ser pues rococó o podía ser neobizantino y Wright era Wright. Claro. Bueno, bien, aquí le puse puesto de la de California, que es la que está tan lejos y me hizo mucha gracia. Bien, entonces yo además, siguiendo con esa carrera de guastavinólogo, como le queréis llamar, me fui a North Carolina, a la Basílica de St. Lawrence de Asheville. Vi la iglesia y vi la tumba. Es que no se puede ser guastavinero si no has visto la tumba. Y además aquí leyendo esto decía, y yacet Rafael Guastavino, eximus arquitectus hispanos insensis animi, obite februari, cuando muere, ¿no? Bueno, bien, que quede constancia el rinconcito que tienen así como rincones de los santos, ¿no? Bien, 2010, el libro de John Ossendorf, una foto del teatro que es más bonito de cómo era en aquella foto anterior. Y aquí la otra actividad que también que ha sido muy interesante para mí es la Bienal Guastavino que se hizo en Vilassar de Dalt por iniciativa del ayuntamiento, que hicimos premios. Aquí está, se hizo una serie de conferencias y aquí está la que ganó el primer premio, esa Megan Rees, Estructural Análisis, tal, que el ayuntamiento la publicó en 3 idiomas, en catalán, castellano y inglés. Es muy bueno, lo que pasa es que no sé si alguno de vosotros lo tendrá, pero realmente es... Y bueno, esto todavía lo pongo porque, oye, esto ya es una demostración de... Esta es la traducción que se hizo a castellano y catalán del libro de José Luis González, que yo tuve la suerte de que me encargaran la revisión terminológica, que es una manera de leer el libro de verdad, ¿no? Y todas las palabras que ya estaba traducido y entonces todos los típicos errores de traductores que no son los típicos de la terminología específica lo hice yo, y esta es la segunda bienal que se hizo y aquí los 2 premios. Esto fue otra de las tesis doctorales que quedó a medio camino. Bueno, ¿qué se va a hacer? Y aquí ya hago referencia a los últimos libros, pero ya ves, ya estoy llegando hacia el final. 2020, aquí el librito este tan bonito. Aquí está esa visión tan chula del teatro. Y luego también la de Benet Oliva, el que era regidor del ayuntamiento y un personaje desde el punto de vista de la política de mucho interés, el que hizo que es conocer a fondo la etapa catalana, pero desde todos los puntos de vista, sobre todo desde el punto de vista personal de Guastavino, que ha sido importantísimo para entenderlo. Y luego, claro, Javier Boro, por favor. Este libro yo me lo compré, por supuesto, y además me compré el audiolibro. Yo paseo mucho por las noches, salgo a caminar y me llevo, he escuchado el Quijote, en fin. No los leo, pero los escucho. Y este me lo escuché. Y os aseguro que me quedé, aparte que es un libro extraordinario, te impresiona decir lo malamente que lo pasó Guastavino. Cuando llegué allí, por favor, yo tampoco lo sabía, esa visión personal. También es muy importante. Y luego la relación, que él explica muy la relación con el hijo. Bueno, fijaros, entonces yo llego a los agradecimientos que me han permitido estar aquí. Naturalmente, el primero, pues Camila y Fernando, que me hayan invitado, por favor, que se lo agradezco, pero de verdad. Bueno, este es Benedetto Oliva, le agradezco que hubiera hecho este libro, que es el de la etapa catalana, pero a fondo, que yo si no hubiera explicado, no podía explicar. Y aquí que el propio Benedetto Oliva agradece a los que le han enseñado mucho, que aquí los tenéis a los cuatro, Sendor, y tal. Lo digo para que yo también estoy agradecido con ellos. Y luego ya una cosa bien curiosa. Yo he cogido el libro de Javier Moro estos días, y le he empezado a sacar un rendimiento que no le había sacado cuando lo leí o cuando lo escuchaba, ¿no? Y digo, bueno, pues mira, ¿a quién agradece que eso es? Y ahora veréis enseguida el porqué. Bueno, están naturalmente Fernando y Camila, luego estaba el que heredó las cartas y que yo creo, porque eso ya son suposiciones, de donde saca Moro todos los dichos del hijo, que el hijo habla muchísimo, yo creo que el hijo es casi el protagonista, ¿no? El hijo que estuvo ayer con Nueva York. Luego Benedetto Oliva otra vez, y en la página siguiente, pues a Rosendorf, la Janet Parks, obviamente, y luego también Ramón Graus, que bueno, pues también yo se lo agradezco ya a través de Moro, que luego os explicará él, que yo me leí su tesis sobre, bueno, la tesis por supuesto la conozco, porque ya a Ramón Graus lo conozco hace muchos años. Pero volví a leer el libro que lo que os explicaré el después, y es interesantísimo también, es que es lo primero que hace Guastavino cuando llega a Barcelona, ¡bomba! La fábrica Batlló, no está mal. Bueno, ya que hemos abierto el libro de Javier Moro, aprovecho y le pregunto, tus entrevistados o leídos, ¿qué te han explicado sobre el Teatro de la Massa? Esta ha sido una pregunta muy interesante, ¿eh? Dice, bueno, las voy a ir rápidamente. Un grupo de 12 vecinos acaudalados decidió levantar un teatro a la altura de esa localidad próspera que contaba con 3 importantes hilaturas. Esto está sacado, bueno, por favor, yo no quiero hacer ahora no, es que está del Benedetto Oliva, que explica todo esto, y luego volveré a esto. Después aquí también, esto ya es la visión del hijo. Por fin en octubre del año 80 le llegó el encargo del proyecto significativo, lo que mi padre había estado esperando desde la casa Batlló, desde la fábrica Batlló. Bueno, tal. Después también la visión del hijo, bueno, tal. Y luego estas son muy bonitas. Hay 2 las que tengo, pero nunca la vio terminada. ¿Cuántas veces hablamos él y yo de la Massa en las noches frías y tristes de Nueva York, cuando arreciaba la crisis y no veíamos la luz al final del túnel? Que es lo que estuve escuchando en el libro que yo os decía que las pasó muy negras, Guastavino. Y luego, fijaros ya 2. Soñábamos despiertos con que un día iríamos de viaje a España, y el hijo lo hizo, a visitar el teatro, tal. Y esta frase es muy bonita. Dejar la Massa fue como abandonar un amante. Estas son las confesiones que tenía el padre con el hijo. Bueno, llego ya al final, estas mis experiencias personales y una conclusión. La conclusión es muy clara. No sabemos de la Massa ni lo que hizo Guastavino como arquitecto. Es decir, proyectó un edificio que nadie sabe si es de él propio o lo copió de algún sitio. Es que yo no lo he encontrado, atención, si algo, no, sí, yo lo sé, pero no se ha publicado. Y Javier Moro no lo sabe. Y si no lo sabe Javier Moro, no lo sabe nadie, porque se ha leído a todo el mundo. Y entonces, claro, yo cuando me empecé a preparar la conferencia que os he dicho antes, hace un mes, yo me encontré, pero a ver, ¿y esto de dónde sale? ¿Y esto de dónde sale? Es decir, bien, pues no lo sabe nadie. Y yo os voy a dar mi hipótesis, que naturalmente, si no tuviera una hipótesis bastante razonable, no habría venido. Entonces son 2 cosas. Esa conclusión que lleva lógicamente a lo siguiente. Decir, bueno, a ver si alguien si la puedo aportar alguna idea. Entonces, ahora voy a ir a toda velocidad. Desde 1861 hasta cuando le propusieron construir el teatro, que son unos cuantos años, pero que no sé si, yo creo que no todos no lo sabéis, porque estuvo trabajando muchísimo. Ya empezó para entrar con la fábrica Batlló. Y aquí lo tenéis todos, aquí ya le copio directamente lo que ha hecho, pero ya lo fotocopio, lo pongo aquí. No sé si me daría permiso, pero bueno, ya está, ya sí lo comentaré. Y aquí está todo lo que hizo. Fijaros, sí, vamos a ir rápidos, ¿eh? Veas también más cosas que yo voy añadiendo. El proyecto de esta casa, el proyecto de la casa de la fábrica Batlló, que os explicará Ramón, tal. Vamos rápidos, ¿eh? Pam. bueno, claro, aquí van apareciendo cosas que luego en la vida económica de la ciudad de Vilasar tienen importancia. Pero, bueno, por ejemplo, aquí es cuando se declara la República, la primera República, ¿eh? No está mal. Yo creo que son cosas que hay que decir, y el sexenio democrático, etcétera, ¿no? Porque él hizo un monumento, por aquí está, hizo un monumento a la gloriosa, que era la República, la gloriosa. Bien, sigue por aquí la tubería, este edificio, la proyecta de Casa de Batlló, al Passeig de Gràcia. Mira, todo esto ya son tiendas abajo, ya eso, pero el resto de la casa está. La casa de Julià, que ha desaparecido, y está esa cosa rara que hicieron aquellos dos arquitectos. Y luego aquí hace referencia a la fiebre de oro, que en la relación con el tema de Vilasar, del teatro, tiene importancia. El gran incendio de Chicago, que influyó tanto en Guastavino, como ya sabéis, cuando fue sobre todo a Estados Unidos. Que se me olvidó decir que también vio, porque él estaba viviendo cerquita del liceo, el incendio del liceo del año 61. También lo vio, es decir, que el incendio, ya lo sabéis que es una de las cosas que vendió con mayor éxito, ¿no? Obtiene el título de maestro de obras, sigue por aquí, su propia casa, la restauración borbónica, se acabó la República y seguimos con los Borbones. Lo de Filadelfia, ya tenía otra casa. Mira qué bóvedas tan bonitas, ¿eh? Ahí, seguro había que hacer una investigación de todas las casas por debajo, que yo por desgracia encontré unas fotos de la librería que hay debajo de la casa Julià, que estaba llena de bóvedas, claro, pero bueno. Esta cosa que se obtiene el privilegio de hacer bóvedas tabicadas él solo. La patentó, como luego lo hizo en Estados Unidos. Aquí también lo hizo, ¿eh? Otra casa, esta es la última que hizo. Y proyecto de la Massa en Vilasar. Ostras. Bueno, pues, ¿qué pasa, no? Algún día se tuvo que desplazar a Vilasar de Dalt para hablar del proyecto con el grupo de vecinos acaudalados, como los llamaba. Y vamos a entrar en esta... Bien, ¿cómo fue todo? Aquí, bueno, ya sabéis dónde está, repito, la población. Fijaros, abajo está la evolución demográfica. Empieza con 3.000 y acaba con 3.000 en los años 50. Pues estamos ahí en medio, en 1880, pues 3.000 habitantes. Y fijaros, yo ahora os explicaré una cosa personal. Yo el año 50 lo he puesto porque yo estuve veraneando con mis padres por estas playas de aquí. Yo era chiquitito. Pero íbamos a los pueblos, y yo lo recuerdo, pero no, de aquella época, de otros años también posteriores, que estaban igual de como eran aquí. Es igual, yo tengo un recuerdo de Vilasar, de Premià de Mar, de todos los de por allí, que eran iguales. El cambio que se ha producido desde entonces es brutal. Y eso también lleva, pues bueno. Entonces, fijaros, aquí lleva la Benet Oliva, que hace historia de la economía, porque tiene influencia, no es ajeno al tema. Hay una crisis, a partir del año 50, del 1850, que había el máximo histórico de población y de trabajadores, etc., hay un bajón importantísimo que llega a la desindustrialización más o menos al cabo de 25 años. Pero, entonces, fijaros que este es el libro que yo he cogido, esta foto está tomada de este libro, esta es una de las calles de Vilassar de Dalt, y a cada lado hay una fábrica a cada lado. Estos son fábricas con telares que sí, que realmente eran muy importantes. Esta foto es del año 80 concretamente. Pero con todo, de la fiebre del oro, a partir del año 75 hay un vuelco importante, tal, por las razones que sean, y al final dice, toda la vida local se reestructura en dos entidades que marcaron la vida local, realizada una y la otra inspirada por Guastavino, la Massa y Camañé, que era una de las fábricas, pero con una pequeña singularidad, que ambas resultaron excesivas para sus promotores, tal como corresponde a los sueños de la fiebre del oro que se estrellaron con la crisis bursátil. Es decir, la fiebre del oro es un momento de expansión económica y riqueza en Cataluña que todos los fabricantes, Sabadell, etcétera, hicieron mucho dinero. Bien, Guastavino está allí, ya conoce la historia y está esperando. Bueno, ¿y dónde se hace el teatro? Pues mira, se hace por aquí. La verdad es que no he conseguido encontrar nada más antiguo que esta foto de Google en blanco y negro, que se lo ha cambiado, claro. Pero en fin, lo importante es que el panadero de Vilasar le compra a un señor de Mataró la finca donde está ahora el teatro. Esta finca se describió así en los documentos: 3 cuadras pequeñas destinadas para telares, todas en muy mal estado, otro aposento que se utilizaba para teatro y 3 habitaciones pequeñas, 2 de ellas en pésimo estado y la restante inhabitable. La superficie de todo son 800 metros y costó 1.300 duros. No he hecho el cambio, pero bueno, era bastante dinero. Claro, yo supongo que llevaron aquí a Guastavino. Mira, no, el teatro está aquí. No hay noticia. Probablemente sí. Entonces, esa sociedad que aquí, que este panadero monta una sociedad, su objetivo, lo tenéis abajo, el objetivo de la construcción de esta sociedad era edificar en la finca un local que pueda destinarse a teatro, salón de baile, edificio, café u otra cosa que acuerden los socios por mayoría de votos. Esto es lo que se encuentra Guastavino cuando va allí, ¿eh? El lugar un poco así como destartalado, podríamos decir, ruinoso. Y esta propuesta tan... Claro, fijaros que de los 10 señores esos acaudalados, el del centro es uno de ellos. El de la izquierda es también de los acaudalados, ya se le ve el más elegante de todos, y no participó en esta, pero el del medio sí. Es decir, imaginar, claro, se los encontró, eran todos pues, de dinero. Es decir, imaginaros a Guastavino con 10 personas con él. No, volem un teatre, Saló de Ball. En catalán, claro, no sé. No, café, ya veurem, no sé, ya veurem. Bueno, no sé qué impresión sacó. Y hay una cuestión que también no hay manera de saberlo, yo no he encontrado documentos, que el día que le encargan, porque claro, a partir del encargo se tiene que poner a trabajar. Y esto se tiene que empezar a construir ya. Pero el mismo día de la compra del terreno ya están trabajando haciendo los derribos. Bueno, y ya siguen y han construido una pared 140 metros. Todo esto son notas ya de este otro autor, que es Samón Fargas. Estas son informaciones sacadas de la documentación que más o menos se conserva todavía allí, ¿no? Vamos bien de tiempo. Bueno, siempre falta tiempo. Ya siempre me falta a mí. Pero bueno, tal, sigamos. Iremos más deprisa. Y el encargo no se sabe. La realidad es que no especifica si se notificó, se podría haber dicho, oye, que vamos a hacer un teatro. Ves pensando, no lo sabemos. Y tampoco se sabe si se lo encargaron cuando ya se formalizó la... Pero el caso es que al cabo de un mes ya estaba cobrando por el trabajo que había hecho de la obra. Chico, lo que sí es seguro es que hizo el trabajo en 2 meses. Hizo el proyecto en 2 meses y empezó la obra en 2 meses. Eso es una hipótesis más de las que yo voy añadiendo, porque ¿no? Pues, tenemos que saber hacer alguna cosa, ¿no? Entonces, fijaros, también he sacado 2 cosas muy bonitas de Moro, que es el hijo dice cuando hace referencia a cuando le encargan MIT y todos los arquitectos la librería, la biblioteca. Y decía el hijo, sentía algo parecido cuando lo propusieron construir el Teatro de la Massa, solo que esta vez de manera más intensa. Hombre, por supuesto, ¿no? Pero bueno, que aquello le recordara a la Massa, ya sabéis lo que es la biblioteca de Boston, que le recordara el encargo de la Massa, es que el encargo de la Massa va a ser muy importante, ¿no? Pero bien, sigamos por aquí. Y aquí también dice, no le vimos durante varios días porque se encerró en su despacho. Esa es una frase muy bonita. Bueno, pues dice, ¿por dónde empezó los días que se encerró en su despacho? Y aquí ya empiezo yo con hipótesis. Todo esto son hipótesis, ¿no? ¿De dónde sacó lo que era un teatro? Por favor, no había hecho ninguno en su vida. Ni había tocado el tema. Entonces, bueno, pues ¿por dónde empezó los días que se encerró en el despacho? Pues mira, los estudios que uno hizo de historia del arte, etcétera, aparte de los de la propia empresa. Y entonces, en ese ambiente de los estudios en Madrid sí que lo tenían y en Barcelona. Ahora veremos un ensayo en francés sobre la arquitectura teatral de Pierre Pat, es un autor francés que yo dice, la mitad de mi tesis está dedicada a él, pero curiosamente no me dediqué a hablar del teatro, porque aquí no habla del teatro, no de la construcción del teatro, sino que habla del diseño, ¿no? De la conformación, Pero bueno, es un libro extraordinariamente interesantísimo. Mirad las láminas las que tiene, y además unas láminas muy bien hechas, el Teatro de Turín, que hace, ya lo enseñaré después, no sé si tendré tiempo para tanto, pero el Teatro de Turín, el techo es una bóveda. Y además lo dice, que la bóveda funciona mejor. No lo digo, con el tema de la bóveda saldrá. Bien, fijaros que él propone la elipse como manera de... Y luego que hace referencia también ya está. Un romano, ya ves otra. Y luego ya los dos que son la típica solución en herradura. Bien, pero no creo que él supiera francés. Sí que está traducido por este caballero, don Benito Valls, que sabía de todo eso nada, pero lo que sí sabía bien es francés. Y sabía traducir el francés, pero muy bien. Yo este libro para mí me lo leí también haciendo la tesis y está un castellano tan puro y era copia directa del libro de Pat. No de esto de los teatros, de todo. Todo esto está copiado de Pat, incluso también de alguno italiano. Bien, este es el índice del libro y aquí al final de todo, ya veis, exterior de la iglesia, fachada principal, campanario, pósitos, necesidad de hospitales, cárceles, teatros. Ya veis. Y al final hay una parte de cada teatro que, como veis, está copiado de Pat. Pero no aquellos tan bonitos no están. Y no está mal, ¿eh? Consideraciones acerca del oído y la vista. Ostras, es que esto sí, en el siglo XVIII, pues está muy bien. Entonces, todo esto es en castellano y yo estoy intentando averiguar de dónde pudo sacar Guastavino su teatro. Este es el Requiem paralel de Durán, que poca cosa pudo sacar de aquí. Y a partir de aquí, esto sigue siendo otra hipótesis. ¿Por dónde siguió? Cuando vio que de los estudios no sacó nada, por dónde los libros se encerró en su despacho. A partir de ahora, eso sigue siendo una tesis y casi es un estudio mío. Es decir, a ver, ¿qué teatros había en aquel momento en Barcelona? Estos son estaba el liceo, que lo tenía muy cerquita de su casa, claro, pero era un cacho de teatro que, fijaros, una sala de 26 metros, cuando él al final la tiene de 17. Otro es el Romea. Siempre fijaros algo con la cubierta, para que veáis, las cubiertas son importantes en esta historia. Siempre son cubiertas de estructuras, armaduras de madera y a dos aguas, siempre, todas, ya las que habéis visto. Y desvelo la estructura, la separación de los muros son 20 metros, pero la anchura del patio de butacas, del patio, como se dicen ellos, es de 16,5. Bien, estos son datos importantísimos que voy recogiendo de todos. Este es el de Zorrilla, de Badalona, muy cerquita, está prácticamente lo que está más cerca de Vilasar. Bueno, ya veis, ya lo veis, está bien, ya vamos a ver, 13 metros y ya no es un cajón. Este es Sabadell, que yo creo que Guastavino los pudo ir a ver, porque no está muy lejos, más se lleva el tren en aquel entonces. Bien, tenéis aquí Sabadell, que esta forma, y bueno, no es la herradura, pero lo intenta, ¿no? Sabadell, bueno, esto sigue siendo Sabadell, perdonad, 17,2 la anchura. Este es el más curioso de todos, Valls. Fijaros que son poblaciones todas de 13.000, son poblaciones grandes, ¿eh? No lo mismo Barcelona, hace falta decirlo, pero Badalona son no sé cuántos. Valls, 13.000. Y fijaros qué teatrito tiene. Es muy curioso, es muy bonito, ¿eh? 15 metros la estructura y 12 metros y miraros el patio de butacas, que es pues, prácticamente una miniatura. Este es muy diferente, llamamos Manresa, 18.000 de habitantes, y este ya tiene voluntad de ser teatro italiano, más o menos. Seguimos por aquí, bueno, 17,6 la anchura del patio. Gerona, que es algo complicado, los accesos, etcétera, es típico italiano. Esto ya es prácticamente una casi copia del libro francés, 17 metros de luz. Y llegamos al más lejano de todos, que es Olot, que es una ciudad pequeña. Bueno, son 6.000, que es el doble, solo es el doble de... Las otras eran 13.000, 14.000, pero esta es una ciudad relativamente pequeña, pero tiene un cacho teatro que es de 1800. Fijaros, aquí se van saliendo los años. Están por orden, si os habéis fijado, están por orden cronológico. Este ya se ve enseguida, 14,6. Y este último es el que se está construyendo o se está haciendo el proyecto en aquellos momentos, 1880, y se construye en el año 82. Fijaros, Reus, 27.000 habitantes, 28.000. hay un dicho que es Reus, París, Londres, que era la relación comercial que tenía Reus con París y Londres por la Avellana, es decir, que era una ciudad probablemente de las más potentes de Cataluña, dejando de lado, por supuesto, Barcelona. Tiene un teatro importante, ¿no? Y 17,3. Vale. Vale, ya vamos bien, ¿eh? Vamos bien. Sí, por 2, vale. Pero lo acabo, ¿eh? Lo acabo. Y por fin presenté el proyecto y vamos a ver el proyecto. Y vamos a ver ya, esto es lo que siempre aparece como proyecto, pero yo he añadido aquí la primera planta ya tomada del libro de Dilmé y Fabré, he copiado sin permiso, pero tampoco voy a publicarlo. La primera planta, y esto, mira, fijaros, no sé si lo veis, aquí están los pilares que son del soporte de la cúpula. No sé si lo apago, lo enciendo, lo hice, incluso son más grandes que los pilares. Y esta es la estructura, que es la anchura de 16,6, y encima de esto está la cúpula. ¿Vale? Bien, pues vamos a ver. Hipótesis propia del conferenciante, es decir, sobre mi persona, el punto de partida de la traza de la planta. Bien, he cogido ahora la planta baja, le he quitado los pilares, le he quitado todos los muebles, la dejo pura y la comparo con las otras plantas que hemos visto hace un momento. La que ya se ve enseguida que no puede ser es la del Romea, que está aquí a la izquierda arriba. Bueno, pues aquí ponemos la masa. Y fijaros, yo el día que puse esto así, dices, hostia, es grandota la masa, ¿eh? Entre otras cosas. Entonces, claro, a partir de ahora es una hipótesis en el sentido muy claro. Se inspiró en alguna de estas. Esto es una hipótesis, ¿sí? Habría que demostrarlo. Pero como punto de partida, como punto para hacer una tesis, no está mal. Entonces, si miramos ya con un poco más de detalle, los dos italianos, los dos de herradura, los podemos quitar. Y de estos, pues si miramos las cotas de anchura, pues este es ya más grande y este es más pequeño. Queda este, que tiene la mismísima cota, 17,3. Esto es así, ¿eh? Bueno, pues vamos a ver qué relación tienen entre ellos. Los pongo así, los pongo así, lo giro, lo traslado y patapum. Está claro, ¿no? Yo no sé si lo copió, si se inspiró. Sí, hombre, está bien. Pero es que coincide la cota, la anchura. Y el primero fue el que ya se estaba proyectando entonces y ya se había empezado a construir. Bueno, esta es la relación de tamaños. Hipótesis de tipografía sobre el origen de la cubierta, la cúpula. Bien, si ponemos aquí esto así, pues mira, la cúpula es el ancho de la estructura del de Reus hasta los muros, y aquí a la izquierda están los pilarcitos que no he puesto ahora. Y si se hace la circunferencia de apoyo en el de muro, sale esa circunferencia que es exactamente la de la cúpula de la masa. Bueno, es así. Y aquí están los pilares. Bueno, alguna relación hay. Bien, es una hipótesis. Hipótesis final del conferenciante. Todo apunta a que el Teatro Fortuny de Reus, obra del arquitecto francés Blanc y Pons, estuvo presente en el origen del proyecto. Este es el teatro. Fijaros, este caballero nació en Manresa, se tituló en Madrid y fue municipal de Reus, Salamanca y León. Al final, bueno, una cosa, si queréis, su tataranieta publica un libro en relación con Gaudí. Porque claro, es que este Blanc trabajó con Gaudí, claro. Y esta ya es una broma, si queréis es una broma, pero le ofrecieron a Gaudí que hiciera el Teatro de Reus. Y declinó, hicieron una especie como de concurso. Y vos ya fijaros, algunos testimonios sobre el uso o funcionamiento del teatro. Fijaros esta foto que ha salido siempre abajo, la he puesto ahora lo más clara posible. Y además, fijaros abajo. Entonces, esto está sacado del libro aquel que hemos comentado. Y el pie, la pie de esta imagen decía: el perímetro de la platea se organizó mediante gradas y un banco de madera adosado a la pared circular. En las gradas, los días de baile, se colocaban las sillas individuales, unas 600, mientras que para las funciones teatrales se situaban en la platea. Inicialmente en la platea no había ningún tipo de pavimento, ni logias alrededor, que se instalaron en 1912. Los días de baile era necesario poner una gran alfombra o moqueta para tal de evitar el polvo. El entablado de madera no se colocó hasta 1933. Fijaros, esto es la primera vida del teatro. Bueno, pues, y entonces fijaros, ahora ya voy a ir a toda velocidad, pero quiero decirlo, ya está. Esta es la sacado una cosa que también es muy bonita, de esto del hijo. Después de explicar, esto es precioso, os aconsejo que lo leáis, que va el hijo a un concierto nada más nada menos que Pau Casals, que estuvo en Nueva York a principios del siglo, ¿no? Del siglo XX. Entonces esto le dio, y entonces dice: me enteré así de que el primer gran fiasco acústico fue el teatro que mi padre que había levantado en Vilassar de Mar. Esta yo creo que ya es bueno, a ver, ya entro ya en acústica y digo que el problema, desde el punto de vista acústico, una cúpula bastante cóncava funciona mal porque concentra. La cúpula más tensa reparte. Entonces, fijaros, la pregunta, le digo, otra hipótesis, ¿no? Si hubiera hecho la cúpula algo más tensa, no habría tenido el problema que tuvo con la curvatura que le dio. ¿Esto lo sabía Guastavino? Chico, yo qué sé, ¿no? Otra hipótesis, fijaros, ya os lo he dicho antes, esto quizá lo estudió cuando hizo, y aquí sí que lo dice, esto es el Pierre Pat traducido por el de aquí, y dice lo que os he dicho antes, que una cúpula va bien, y que, pero que sea más bien poco cóncava. Bien, esto queda así, y ahora acabo. Esta es la penúltima, tranquilos. Digo, hombre, esta es una de las fotos, una de las imágenes que yo puse porque yo también hablé en la otra sesión, estuve hablando de San John de Divine, y el cupulán, que esa es otra. Pues aquí está en la misma escala, Y fijaros que si trasladamos a San John de Divine, sale una cúpula más poco tensa y se aguanta, porque esa está ahí construida desde hace ya 100 años. Y esta habría sido una solución posible. ¿Alguna conclusión más? Sí. No hubo que esperar a los años 20 para hacer una lámina de 5 centímetros. Es decir, que una de las afirmaciones de Santiago Huerta es que como gran cosa es que la primera lámina que se hizo del mismo grueso es de los años 20 y lo hicieron los con hormigón armado y tal. No, si vais a finales del siglo o a principios del siglo XX ya estaba hecho igual que incluso, bueno, con la luz 29 metros que tiene San John de Divine, ¿no? Bueno, pues gracias por vuestra atención. Gracias. Bueno, ya está.
Muchas gracias, bueno, por agilidad. Vamos a dejar todas las preguntas hacia el final. Vamos a pasar ahora, vamos a cambiar un poco el turno. Va a venir ahora Ken Diebold y seguimos dando tiempo a Derek, que parece que está todavía con algún problema técnico. Por favor, Ken. Pero Derek está, o sea, no está en Valencia. Hemos comido con él, o sea, que está por aquí. Bueno, voy a presentar a Ken Diebold, que es un amigo de 21 años. Madre mía, me ha recordado ahora José Luis. Gracias a esa organización, pues recuerdo una cena que estábamos cenando juntos y ahí arrancó una amistad que llega hasta hoy. Bueno, Kent es socio de Vertical Access, una empresa fundada en 1993 que utiliza el acceso vertical, digamos, para hacer estudios previos, inspeccionar, documentar los edificios en todo Estados Unidos, ¿no? Y su primer contacto con edificios de Guastavino fue en la iglesia de San Tomás, en Manhattan, hace 30 años. Y este trabajo le dio, digamos, dio paso a un viaje de descubrimiento de todo lo que relaciona con Guastavino y que, digamos, expandió mucho sus intereses y sus profesionales y personales. Quien dice o afirma de sí mismo que no está formado como teleco, digamos, sino que ahora veréis un poco su formación y su forma de trabajar a través de varios ejemplos de estudios. You ready?
Almost.
Yeah, okay.
I'm completely changing platforms here. There we go. Okay. Thank you, Fernando. Thank you for having me here, hosting me once again in this beautiful city. All set? All set? Can I be heard? Everything good? Yeah? Okay, nice. Thank you. This is probably going to be the least academic of the papers that you'll hear in the next few days. And what I'm trying to do is kind of tie together my personal Guastavino story a little bit with some of the technological advances that we've made or participated in over the years, but also, well, you'll see. So I'm going to start with this. Jose Luis, I love your timeline. That's great. And I would like to invite you to add to this one. So this is something we worked on. Okay, so there are 4 streams of time. This is to portray the life of Rafael Guastavino. And the first stream of time is building technology world events. So the Chicago fire is here and the development of modern building codes and that sort of thing. And then the biographical stream of time. And I bring this, part of the reason I'm presenting this at the outset here is to illustrate to you the importance of both the father and the son. And in the United States, when we talk about Guastavino, we conflate the two. So anyway, this is the biographical part of it. It's the life of Guastavino, the death of Guastavino, the father, and so on. And patents and publications, which were very important to the development of his and the acceptance of his technology in the United States. And here, the last stream of time are his projects, some of which, particularly those in Spain, were his work as the primary architect, and then the balance are largely when he was a design builder for the vaults. The sound is still good? Yeah, great, thank you. So, and the reason I'm emphasizing this is to demonstrate the sheer number of projects that Guastavino built in the United States. We estimate around 1,000, which is a lot. And many of them, Boston Public Library, many of these are some of the most important architectural, all the buildings that we have in the United States. They're revered. They are heavily occupied, heavily used. And many of them are monumental historic buildings. So we're dealing with large buildings. So this goes on, and what I would like to do is offer to share this timeline. If you can take a picture, I could share it later. I'll leave it up for a minute. And the idea is to sort of crowdsource as much information as we can. This is in its native form, an AutoCAD DWG file, and I'd be happy to share it with anybody who would like to add some additional information. Jose Luis, you in particular have something that you could just drop into this. That would be great. So we'll move on from there. So I have I had to have a title for this talk, and so you've seen that. But I later kind of came up with an alternative title, which is Guastavino. Is it safe? So Guastavino going back some years, very little was known in the United States about Rafael Guastavino, father and son. And the question that I often get to deal with my clients who are largely architects and engineers is it safe? And so we've done a lot of these projects over the years, and answering that question in a litigious society such as ours in the United States is it's not an easy thing to accomplish. I want to acknowledge some other people that have put a lot of work into this subject matter. One is Berta de Miguel, who's a graduate of UPV, did her PhD thesis on non-destructive testing in the United States with a focus on Guastavino evaluation. The other is Kelly Streeter, who's a licensed structural engineer and one of my business partners, who's also very qualified in the world of non-destructive testing. My personal history starts at St. Thomas Church in Manhattan 30 years ago. At the time, I was in a project meeting with the architect, Jim Rhodes from Fire Blender Bell. The structural engineer was Silman. It was my first project with both of them, and we're still collaborating to this day. The idea was to do, using our access system to get around on the building, to do some evaluations and documentation of the exterior of this church, built in 1914, and the interior. So these interiors are difficult to evaluate visually. It's 30 meters to the top of the vault. The lighting is not very good, and getting access to be able to do some hammer sounding or some sounding of the tile, which is the only definitive way to say it's safe or not safe, is very difficult. So we were hired to look at a few locations that were identified by the design team as being suspect for some reason, mainly because there had been some leaking and signs of efflorescence, salts that had been deposited. And we looked at, I don't know, 3 or 4, something like that, locations in the church. Jose Luis, when I put this slide up in 2004, this got a big laugh from the entire crowd. So you can all laugh now, but this is how we determine whether Guastavino is safe or not. Whether it's here, in the new world, in the old world, it doesn't matter. And the choice of hammers is, yeah, that's kind of up to you. These are challenging spaces. And this is St. Francis de Sales in North Philadelphia. It's one of 2 broad types of Guastavino structures that we have in the United States. One where the extrados of the dome or the vaults are the exterior of the building, and in other cases where there's an interstitial space that keeps the vaults dry over time. As long as that roof is maintained, they're kept dry. This is the Oyster Bar, black and white historic photo of the Oyster Bar. The story goes that one day people were having some lunch in the restaurant, and a piece of the raised mortar joint fell into somebody's soup, kaplunk, like that. So the question was, we can all say it, right? Is it safe? And so we were hired to go in and make an evaluation of that with Silman, with that office. So we worked in the middle of the night because the restaurant was occupied otherwise. And I think you can see, if I zoom in here a little bit. So there's a bit of that mortar, that raised mortar joint that's missing, that's fallen off. For the most part, there was an intervention done here, but some years later, probably 10 or 12 years later, we found very little in the way of dangerous or distressing situations. This is a train station in Toronto, Ontario, in Canada. And they were doing a project similar to what they've done in Grand Central Terminal, which is to bore a tunnel underneath the existing train station in order to bring in some more trains, some more concourses. And we got a call from a Canadian architect who said, can you come up and take a look at this for us? Derek and I worked on this together. It's a complicated structure. We're going to hear a lot about train stations a little later in the week. It's a very interesting building construction typology. And in this case, they wanted to know if it was safe or not, but all they would give us was one tower of scaffolding to be able to get up and do a little bit of hammer sounding. So we looked on the inside in the attic at the extra dose, and we did a little bit of hands-on and said, well, it looks pretty good. Not a satisfying answer for an engineer. This is the Buffalo Terminal train station in Buffalo, New York, near where I grew up. I remember going into this space when I was a child, picking up grandparents from the train. And I had a deep personal attraction to this building. The building's now going into construction in design, and we're going to hear probably a little bit more about that later in the week as well. In this case, we could reach almost everything. This was the biggest lift that we could get into the space. And we couldn't quite reach the top of the barrel vault, but we got most of it. Asheville, North Carolina, the Basilica, where Guastavino is encrypted. Again, we were asked, what can we do here? And we inspected the outside of the building. We came inside, and with the furniture, the pews on the nave floor, we couldn't move them around. So we ended up flying a drone in here. Now, flying drones is very difficult indoors. In particular, this is covered with a copper roof. So there's a Faraday cage that's results. And the Faraday cage prevents, and the construction of the vault prevents any connection to GPS satellites. Most of the stability of drones is due to being locked into all of these satellites in space. So this was a difficult flight, and we couldn't tell much based on the visuals. We also flew it with an infrared camera after a rainstorm, which helped us to focus a little bit more on where the leaks were in the roof. Another example, this is the subway exit, entrance and exit at the municipal building near the Brooklyn Bridge. Many of you may have been here. If you've made a tour of Guastavino structures in New York, this is a marvelous space. But again, very difficult to evaluate due to the traffic and the size of it, and the fact that the extra dose is unavailable for getting to. So the last example here is Ellis Island, which was renovated 40 years ago when it became a national park. Ellis Island is where, I don't know the number offhand, but let's say 1 million or several millions of people came through, immigrating from, well, largely from Europe. And despite decades of neglect and abuse, the water ran through this building for decades. There were around 8 or 12 tiles that were actually replaced. Okay. Before I shift gears a little bit, this is a large crowd. There's a lot of experience here dealing with timbral vaults and segmented vaults and this sort of thing. So I'm going to ask a question, and I'll ask for a raise of hands. So in any building that you've been familiar with over the years, can you think of an example where the roof has been well maintained and the water is not getting into the building, where you have observed a tile or a collection of tiles fall out of the sky? Anybody? Have you had this experience? Anybody? No. Okay. That's interesting because there's a lot of it here, and I have never seen it either. Okay. So let's see my timeline. St. Thomas Church, 30 years ago, came to the meeting in Barcelona that José Luis organized in 2004. And I think maybe 2005, Fernando, well, at that conference, I met a lot of very interesting people, including Fernando. And Camila, we did not meet because you were not there in the afternoon that we met later. Anyway, so Fernando and I were able to go visit this building site, which is now, it's in the Pyrenees, north of Barcelona. And it's a cement factory. So this is the limestone quarry in the back. And the whole process was gravity fed. So down through, grinding and sorting and everything else. And down here is a train siding to load trains with the cements that went out. So you can see here that this is partially restored at the time we were there. And that you can see here on the left, these 3 vaults were being constructed when Fernando and I were there in 2005 or 6, something like that. So as a result of that, I was invited to come back and work with a group of very experienced paletas who were very gracious to me because I was not so good with this. And they showed me how to build simple vaults. And for me, this was a great experience because there's nobody in the United States at that time who could just build a vault like this from scratch. It's not that long ago. And it's amazing that we have 1,000 of these buildings in the United States and nobody knows how they were built. Okay. So I came back from Catalonia on that trip. And then I decided to try and make organize some workshops. And we've done a few of these now. One was with John Oxendorf in one of his test vaults. So the year might be 2008 or somewhere in there. This was APT in New York City, and I'll let this play. It's time-lapsed. Berta de Miguel helped with this significantly. We did, and we had a good time. This was really a lot of fun. And we had architects, we had engineers, we had conservators, historians, trying to get as many people to come and have their hands in the pasta and actually understand how to build these things. This was quite successful. We built 2 different types of vaults over 2 days. So pretty short. A lot of the preliminary work was already done. And it was a success. And we've done a few more of these at another APT meeting. This was APT in New York, another APT meeting, and several others, one of which I'll talk about again in a few minutes. So always, everybody wants to stand on the vault at the end of the day. Okay. So this is another one that we did at APT a few years later. Different people, different group of people. Derek and Tim were both there, participating and also helping out quite a lot. And I'm not going to talk about the vault collapse. I'd be happy to talk about it with somebody at some point, but we did have one vault collapse, which is good. You learn from your mistakes too, right? We're going to hear a lot about this later. I'm not going to steal your talk here, but this is a huge project going on in Detroit, Michigan, and again, a building seriously neglected for many, many years. I was going to share some of the before pictures, but I'll leave that to you. It looked terrible. I mean, there were literally tiles falling out of the ceiling. So we got involved in a very small way in this project. We were contracted by Lytle & Hart, which is a contracting company that won the award for doing the work on the extradose of the vaults, which again had water running through them for many years. They were going to be responsible for some excavations for probes to look at the embedded steel, and also to repair and replace some of the hollow sounding areas where the vault was no longer complete in section. We also took it upon ourselves as an internal research and development project to continue using. We've had several iterations of this already, but to continue using more contemporary ultrasonic pulse velocity equipment and surface penetrating radar. And I'll just abbreviate those, UPV, SPR. I'm not going to get into much detail with this. I'm not a teleco. I could kind of bluff my way through it, but there's no sense in that. So in the course of building this demonstration vault, or a learning vault for the masons, we simulated faults that were meant to be interruptions or delaminations in the vault at various depths through the section, and we built up quite a section at one point, and faults of different types, different thicknesses, and so on. What we found is that okay, so here's a picture of the vault that we're working on with a few. You see my pointer? Yes. So here's a simulation. Here's another one. Here's another one over here. And after we got finished building these vaults, they remained in place for a few weeks. And Kelly Streeter came out. She didn't know where the faults were, where the problems were, the delaminations, if you will, and she was calibrating her equipment, and it's sort of a final proof of concept, and it worked. And I'll talk about that a little bit. Ultrasonic pulse velocity uses sound and the return time from the backside of the fault, either at the fault or at the backside of the vault, and worked seamlessly. We also found that we could estimate the thickness of the vault, and a little more on that in a few minutes. Also, the new equipment. So our early work was with a very primitive receiving unit and a hammer. Hit the vault, read the impulse, and then calibrate and so on. It's pretty complicated. So the UPV test results were positive. We could detect delaminations, depth of the assembly, and these artificial reality enabled us to come up with some graphics where you could actually visualize what was going on within the vault. And by overlaying that onto photos of the vault, it became very clear what was going on. Surface penetrating radar uses another frequency of energy to, and again, looks at return time to determine what the distance is to a delamination or to the backside of the piece of interest. It's very important to establish the dielectric constant, which goes into the formula that the machine, the black box, the little black box, spits out. And it's very important to optimize that for the material that you're looking at, and to determine how variable that dielectric constant is across an area. Again, real-time visualization, which allowed us to do things like this. This is the delamination that Silman had marked out, and this corroborates it pretty well. So here you show a delamination becoming more and more solid through the profile of the tile. This was the better of the two technologies. We had clear delamination signals, very accurate, and we could confirm the accuracy with the known voids on the test vaults that we had built. I think this has already been summarized, so I'll move on. There's Kelly with some of her equipment up in the attic of the vault, and her summarized findings. Again, the sound's good. I'm speaking into this well enough. Everybody's good. Okay. We looked at 25 locations and corroborated all of Silman's markings. In some cases, we were able to modify the scope of the work a little bit for the contractor, so they maybe didn't have to do quite as much as they had thought, or maybe a little more, and maybe in a different direction. This also, what we discovered is we have now a tool for looking at vaults that we don't understand the physical properties of. So, in a large dome, for instance, St. John the Divine, the walls of the dome start out this thick, and at the end they're only 3 widths. So in order to model that, you would have to know what what the vault thicknesses were at various elevations, and we can do that reliably now without having to take it apart or drill holes through it or what have you. Now, Berta's thesis work. Berta worked with us in New York for 7 years, so she encountered a lot of Guastavino while we were there working together, and she came back to Spain and began working on a PhD, and this was her PhD project. So her focus was were twofold. One was to do a survey, a literature search, if you will, but a survey of all of the different non-destructive technology techniques that were being used in the United States on heritage buildings. And the things that she focused on, that's the first part of her thesis. The second part is to evaluate Guastavino tiles using these primarily four technologies. So she used SPR, ultrasonic, impact echo, infrared thermography, which she found to be very promising, although not in the passive sense. So you had to actively manipulate the temperature of the substrate in order to get results. Yeah. So, we did our first mock-ups with John Oxendorf in the vault that he built at MIT, using by today's standards, very primitive technologies. We determined that we could find the vaults, and we have confirmed that with better equipment, more expensive equipment. But similar to tapping on the vault with a hammer, so that if you think of tapping on a vault with a hammer as the past, it's still the present. That hasn't really changed. This is the only conclusive way to do this at scale. So similar to hammer sounding, both techniques require close contact with the substrate intradose. So there's no remote technology for evaluating these tile vaults. Both are limited to localized samples. It's not practical to do vast areas, whether from the top side or the bottom side. Both require a lot of time and effort to collect the data and process the results. And even though sample size can be significant, 100% coverage is impractical. And when the building owner wants to have a determination, definitive, is it safe or is it not? It's still very difficult to come to that conclusion. As recently as a few months ago, we were back at St. Thomas Church performing the same scope of work that we did 30 years ago. So we're back there looking at the entire exterior, the entire interior. This is a photo of the extradose, the top side of the vault. And one thing I find very interesting here is that, and I found this in the archives, I'm just going to mention it briefly, but this is an intervention by the Guastavino company about 5 years after the vault was completed. So somebody detected some movement or some problems with the groins, the nerves of the vaults, and they actually put some reinforcement in here. And there's one sketch, one drawing in the archives at Avery Library on this subject. So we spent a couple of days up in the attic mapping all of the little cracks in the hairline, this and that, and really found nothing of any significance or that was at all alarming. So here we are 30 years later, still trying to tap on the vault with a hammer. We did an exhaustive visual survey, provided supplemental lighting, very high wattage light output, theatrical lighting, and did a survey remotely with binoculars from the ground, as well as from the triforium level. So we tried to get different light, raking light, changing light, and really did not find anything that was obviously out of place or out of character for a Guastavino vault. This is a reflected ceiling plan, and you can see the 3 red circles are locations that we went to and did a little bit of hammer sounding. So again, you're hanging from a rope like this, and you can reach here and you can reach here. It's a very limited amount of vault that you can actually get your hands on. The blue circle was another one that we lit up and we did a live feed video with the entire design team. So, what's the future? What are the possibilities for larger scale, remote, non-destructive test evaluation techniques? And from Berta's research work, we know that infrared thermography is a possibility. Laser interferometry is not something that she looked at. It's a technique that's been around for quite a while. And it involves using multiple laser beams and looking at time and frequency changes between the differences between those different streams of light to make some conclusions about vibration, whether there's movement, any movement at all in the vault. And then this is a little bit, we say tongue in cheek, but artificial intelligence, because as we all know, right, artificial intelligence is going to use up all of the electricity in the world. It's going to put us all out of work, and it's going to solve all of our problems, whether we know about them yet or not. So, infrared thermography. This would be great if we could thermally control that enormous space, either inside the church or outside in the extrados in the attic. This would require ideal and predictable temperature conditions. Very difficult to influence these or control, especially at this scale. Temperature control may not be possible at all if there's no attic, if it's one of these vaults or a dome where the extrados is the roof. Temperature differentials, which is what we're looking for here, may be fleeting. I mean, even in the course of an hour or several hours of examination time, those temperatures could change quite a lot. So the lack of certainty in the result of knowledge in the thermal dynamics is not well understood or consistent, and is in itself probably a PhD thesis. One of the things that we have talked about doing, and Berta didn't do this, she had a test vault that was a couple of meters by a meter wide, multiple withes in different parts of it, and that's what she had to work with. And she didn't try, I don't think, so everything that all the heating and cooling she did was by convection. But I'm thinking that direct contact heat sources, like an electric blanket, a large industrial electric blanket, if you put it on the top of the vault and you give it a dwell time of maybe 3 or 4 hours, and then shoot from the below with an infrared camera, you should be able to detect the difference between laminated and delaminated tiles. That's, I think, a promising future, but again, very difficult to cover the entire vault in a blanket and control the temperature. So, how's my time, Fernando? Okay, perfect. Great, thank you. So, in a very simplistic sense, and I had some graphics I was going to try and share with you, and I knew I would, since I'm not trained as a teleco, I would be very kind of mumbling about it, not being able to speak very well. But simplistically, I've already explained, this is specialized LiDAR, pretty expensive equipment. It's not the kind of LiDAR that you would use to scan a building facade. The idea is that you can measure differential movement at scale from a distance when the vault is stimulated acoustically or mechanically. So these are two different techniques that need to be looked at. 2005, the first time I heard about this, and in the United States, I think there are several papers doing a literature search. Most of the work is coming out of Europe, and much of it is some of it, a good part of it is coming from UPV with another professor in a different department in geomatics, I guess, right? José Luis Lerma, who I'm having a meeting with later in the week. Most of these citations that we found, the application of laser interferometry to heritage buildings has to do with mosaics, decorative paintings, plasters, and other artistic or archaeological works. None of these are as massive as a Catalan vault, Guastavino vault. So specific challenges to this technology. The distance between the scanner and the interdose of the vaults that we work on can exceed 100 feet or roughly 35 meters. The current range is 50 meters. The problem is that you have a dispersion of light over distance. And so the density of the light streams or particles becomes less and less as you go out further in distance. Similar to light, sound attenuation can be a problem over longer distances, but in both cases, the best result is going to be when the sound or the light is hitting the vault perpendicular or normal to the surface. Now, that's a little difficult to do on compound curves with vaults and domes and things like this. So these are all things that we have to figure out and determine whether we can make it work. The other issue, right, has to do with the mass of a single tile, which is about 1.5 kilograms. So it's a lot of material to excite enough to cause just a little bit of vibration, just a little flutter. This is I'm wrapping up here, but this is a moment to kind of reflect. The challenges, as you see, are many, and they're serious. Maybe they can be overcome, maybe they can't. But my thinking is that even if we can learn enough about the technique and this particular material, if we could get it to a point where we could evaluate, 20% or 30% of a vault rather than 4 locations that are 2 meters across, I think that's an improvement in the technology, and it's another step toward being able to tell people, yes, it's safe, or we have concerns. There's some movement over here, we see a little over there. We're extrapolating now to the rest of the vault. There may be issues similar in other places, and it's the scientific method. It's how curious minds solve problems and come up with different solutions to and different applications for existing technology. This is the unfinished staircase at the Basilica of St. Lawrence. I think it's a beautiful structure, a fine thing. The second time we've seen this now, Rafael Guastavino, this is his vault, his crypt. And this is a moment for me to kind of pay homage to him and his son, because this has been such an interesting journey for me over these last 30 years. In a professional career that did not start out working in this field at all. This is perhaps a shameless plug for our book, which is available downstairs in the bookstore. And also to point out that the 3 authors, Berta de Miguel, whom you've heard of, myself, and Virginia Lorente, who did all of the illustrations. Berta and Virginia both went to school here in Valencia. And I guess the reason I have this up here is to emphasize that once again, you can see that Valencia is the center of the Guastavino universe. So thank you very much. You're going to have to move this. Is he already on here? I think he would. Tim, is yours loaded already? Yes. Yeah, okay. All right, so I'm going to, you need to move this over, I think. Yeah, plug it in. ¿Está bien? Ahora hay que darle cuando cargue. Bueno, pero tú que yo estoy aquí.
Bueno, mientras acaban de instalar, bueno, creo que Derek ya tiene prácticamente todo esto organizado. Lo volvemos a correr una conferencia y Derek hablará después del descanso, ¿no? Después de la conferencia de Tim. Bueno, Tim es un ingeniero estructural belga, para más datos, pero residente en Nueva York. Es un ingeniero restaurador que combina lo que es la ingeniería, la artesanía tradicional, la investigación, la sostenibilidad. Es asociado en uno de los estudios de estructuras de Nueva York más conocidos, el All Structure Engineering, y es también profesor adjunto en la Columbia University y está especializado en el análisis, la reparación, la restauración y la rehabilitación de estas estructuras históricas, incluido edificios de tierra o bóvedas tabicadas en zonas sísmicas, ¿no? Y al mismo tiempo tratando de que todas estas tecnologías o estas reparaciones pues tengan la menor traza de carbono posible. Bueno, os dejamos con él.
Muchas gracias, Fernando. ¿Me escuchan? Voy a dar esta charla en inglés, pero quería agradecer Fernando, Camila, Lidia para organizar todo. And, just I'll talk in the language of the Guastavino company, which was English. So we've seen a bunch of overviews of projects, a bigger picture on the Guastavino company. I will go in depth on this one case study, which is the spiraling staircases of St. John the Divine. I will talk a bit about construction history, documentation, and structural analysis. And this work was done in collaboration with two other people, Anna Gasha and Carlo Olivieri. Let's see. So this is a staircase I will talk about, and just take a moment to admire it. I will show this photo a couple more times because we'll need to come back to it. But it's really quite magnificent, arguably the most beautiful staircase in New York City, maybe therefore the world, as New Yorkers would say. As Fernando said, I work at Old Structures Engineering in New York. We are a medium-sized engineering company. We work on Guastavino vaults, like the one shown here on the right. That's the Dividend Hill Monument in Newark, New Jersey. But it's only a very small portion of our work. We work on the lighthouse at Fire Island with Kent's company, actually. We do structures in Central Park, like the Gothic Bridge shown here, a 1960s cast iron structure. And I work a lot in Peru on urban architecture. With the Ministry of Culture there, and a variety of other things. While at Old Structures, as I said, I do only a fraction of our work on Guastavino, where I teach at Columbia University. We are sitting literally on top of the Guastavino archive. So we have the whole collection of drawings that was rescued by George Collins, who was mentioned before when the company shut down. So you can come to us and you can actually handle the pieces of paper that the Guastavino company and the Guastavinos were drawing on. We also have a series of buildings, right? Arguably the most beautiful Guastavino work in the United States is St. Paul's Chapel. It's attributed to this architect, Isaac Newton Phelps Stokes. So he was a very young architect who worked with Guastavino. And when you go there, he's like, who's the architect of this building? They tell you, I.N. Phelps Stokes. And after this building, he did a bunch more, and none of them got the amount of credit that this one got. Because look at this space. This is pure Guastavino. There's some research there. I won't get into that in detail, but we have other buildings that I think tell other stories about the Guastavinos on the campus. So we have Kent Hall and Earl Hall. We also have Prentice Hall, and that one I want to speak to a little more here, because this chapter is called Guastavino, Father and Son. Well, John Comerma was the guy who, when Guastavino Sr. died, said, I don't want to work with Guastavino Jr. I'm going to start my own Guastavino company, the Comerma Company, and started building Guastavino vaults, right? Guastavino then sued him and he was put out of business very soon. But so when we talk about the Guastavino Company, there were many people working there. There were many very skilled masons, many skilled people who are not getting the Guastavino, who don't have the Guastavino name, don't get the credit, and we know very little about them. And maybe this is my call to arms. We should maybe look into them. and a little bit more and try to see how they contributed and what happened there. But that's not the focus of this talk. What else we do at Columbia is I teach students about Guastavino, right? I have a course in traditional building technology. I teach about embodied and operational carbon. And it's nice that then when we do those classes, we can use St. Paul's Chapel as a case study. There is a competition every 2 years. It's actually an international competition on arch construction. And every 2 years, students need to build an arch. And not coincidentally, every 2 years, my students built a Guastavino arch, not only because it's the easiest, but also because I've taught them about that. And then we have also student research on the topic. So I myself don't have a research position at Columbia, but I guide it for other students. And so this is work that Erin Murphy, who now works at WisJenny in Boston, in an area with lots of Guastavino vaulting, and I think she's working on the Boston Public Library now, did in collaboration with myself and with Derek, who will speak next. And we really looked into how does the shape of a vault intersect with the use of formwork and the use of mortar in Guastavino vaults. Because it's not as easy as or simple as some of the literature explains. Like the easy way that's often is explained that Guastavino vaults are built is you do this without formwork. You take your first tile, you stick it to a wall or whatever with gypsum mortar, right? The part that has the tensile strength, and then you go over with Portland cement mortar. It really depends how it's done on the location. John Oxendorf likes to joke that Guastavino vaults are like children, right? You've seen one, like no two are the same. And so here you have the Cathedral of St. John the Divine, the construction of the crypt, where essentially the vault is being built with formwork and without gypsum mortar. So it's entirely laid in Portland cement. So if you want to know more, so we collected actual samples at the chapel of St. John, at the St. Paul's Chapel at Columbia while they were doing the renovation. This is Derek in the photo and me picking off like a piece of the mortar so we could analyze it. And so depending on the location here, there is like natural cement and lime used in the mortar. There's Portland cement used. There's gypsum and lime used. There's just gypsum plus lime used here. There's just gypsum used. So depending on the location and on the way they needed to construct, different mortars were used. That's all collected into Erin's thesis. So she did a list of projects where she was able to gather the types of mortar used and then link it to the formwork and did all these sections. So you can look back at this. If you want to, this is all the workshop that Derek, Kent, and I organized with APT in Detroit. Kent already spoke about it, but so another part of this is like educating other professionals. That brings me to staircases. That's what I really want to focus on. And so the history of Guastavino staircases in New York start really early. So he arrives in 1881. His first patent in 1885 that Guastavino files is for partitions. And then the second and third one, so the second one or third, they were filed at the same moment, is for staircases. And the other one is for vaults. I do find this language quite funny because it says, I, Rafael Guastavino, have invented, like these staircases in vaults, like, which is in a way absurd, right? Like it's only in the United States where they think they are exceptional and can really reinvent things, and like where the whole patenting in the 19th century is really crazy. You can have a lot of fun looking at old patents. But so essentially he explains here how these stairs are built. So, right, you have your 3 layers of tile. Typically the curve here in the elevation is because there's like a 3-dimensional part to this, right? That's this part of the curvature. I'll get into this more. I'm showing this because this was clearly on his radar right away when he started the company. So they advertised staircase construction quite heavily. He's saying that this is costing less than iron or other fireproof construction. In the archive, we have plans and sections of typical stairs. For example, this one from before 1910. This one is actually supported on some steel stringers. You have your 4-inch section that's about 10 centimeters. And then they call for a plaster finish or an acoustic tile or finished however you want. And here you see in these details, some pieces of steel that are supporting this staircase. This is not how the one at St. John the Divine works. That one is quite more complex. I'm just showing you for like the general context. Like they were building staircases wherever someone would let them build these. And it's taking this tradition that is solidly ingrained here, right? So they're not doing anything particularly new. The Guastavino company was very good at marketing, so they took photos in the right moment. So this is when they were building the first Church of Christ Scientists in New York. So you see, this low test that they were doing before they installed finish tile. So usually the way they built these is they used their rough tile, in this case, probably set with gypsum cement. You can see it because of the bright white color. And then they would put stick from the bottom a soffit tile to that, and I'll come back to that. This is probably maybe one of the most famous of their staircases, just because John Oxendorf put it on the cover of his book. It's the one at Baker Hall in Carnegie Mellon. It's truly spectacular. If you ever find yourself in Pittsburgh, maybe a visit to Frank Lloyd Wright's Falling Water, as indicated earlier in the first talk, then you're nearby and you can go take a look at these. But going back to St. John the Divine, right? I want to spend the rest of my talk focusing on this particular one and helping you understand how it came to be, how it works. So this was done with Anna Gasha. She just finished her PhD at Columbia in Historic Preservation, who did most of the archival research and documentation. And then Carlo Olivieri is an assistant professor of structural engineering in Naples, and he did most of the structural analysis. So the Cathedral of St. John the Divine, located in uptown Manhattan. I assume Derek is going to talk more about it afterwards. So I'm not going to go in tremendous detail. So this was where they constructed that massive dome, right? It's here in their advertising image. There was supposed to be a big tower, but instead the crossing of the church is covered by this temporary dome, which has been there now for, I don't know, Derek will need to give you the answer, but I think more than 100 years. I think 115. I think it was built in 1910. The church itself is unfinished, but the staircases I will talk about were built from 1909 to 1911. What's interesting about this church is that there are tons of Guastavino vaults everywhere. They were built under 2 different architects, and there's a wide variation of tile and of types of construction that's there. The first mention of our staircases is 1904, because we have some cost estimates that list 2 staircases with 2 turrets, but it's actually built later. So this is, when I say 2 staircases, indeed, there's one where Heresy, I think, they put all these cables through. So this staircase is an almost identical copy to so this is the northern staircase. It spirals clockwise. The southern staircase is spiraling anti-clockwise. Interestingly, I don't know why. It was a very it was a thought out decision though to do it. I know that for another reason, which I'll show later. Everything I'll show you later will be on the southern staircase, just because it doesn't have the ugly cables running to it, and this one is more accessible. And when I was talking to Gabi Pardo, who is also a graduate from the UPV program, he said, "Oh, Guastavino must have been inspired by La Lonja de la Seda, Valencia. And I was like, well, what do you mean? So I went this morning and I asked very nicely to the people, can you open the door? And so they let me up here. And so when you listen to the audio guide in La Lonja, they tell you, well, for a master builder, for him to like put his signature on a building, he needed to put in a special staircase. And so I think of this of this staircase, which I think is incredible, as kind of Guastavino's answer, because he must have seen this, right, to La Lonja. There's quite some differences though. Here, of course, it's not a tabicada. It's built in full masonry. But note, like, right, that there is no central column in this staircase, which was originally intended to be here. I'll talk more about that. So we documented the staircase, taking hand measurements. We took photographs, and then we did a 3D laser scan. I was mostly interested to see, like, between the different levels, how much variation is there in the geometry. And I cannot tell you exactly enough, because we used our laser scanner, and when I put this model in the computer, I couldn't really accurately detect the differences. So it's very closely built, but because we're dealing with these ribbon joints on the vault, right? Those ribbon joints don't always perfectly line up. So that leaves you like half a inch, like 1 centimeter difference, like from floor to floor. And that is roughly the variation I see in my laser scan. So, you know, I can only tell you it's very close, like repetitively. So it's incredibly accurately built, but I cannot tell you how close, because I don't think my scan is good enough. Here's another view of that staircase. This is a view from the top. Note, you know, the beautifully glazed tile, the finish here. There was at some point talk about like the color of the stone. We have quite a lot of records of this. Just to give you some data on this, we have 202 steps in total. 170 of those go up. We have 11 spirals. The headroom varies, but it's roughly 2.4 meters. So you could actually tap every single tile, Kent, if they ever commission you to check it. We have, like, in terms of dimension, there's an inner core of roughly 61 centimeters, and then the actual stair is 91 centimeter from the outer point of the inner core to the furthest point. So you have like a diameter of roughly 3 meters. The finished tiles, the sort of soffit tiles, are 18 by 9 centimeters, and this is the 1908 drawing by the Guastavinos of the staircase. Here's an other view from the top. So at the top, there's like a wall going up, and then a cupola. The wall at the top with the cupola and the weight that this gives actually helps in the stability of this. So it's important it's there. From our archival records, we know that this staircase was not in the original plans for St. John the Divine. So we don't find anything on the 1892 drawings, nothing on the 1895. But then in 1904, we see that there's a cost estimate for 2 staircases and 2 turrets. And we have a contract with the Guastavino company from 1906 that says that the entire glazed style staircase with glazed style risers and slate treads and platforms, also a central column of brick lined with glazed tile. So there was supposed to be a column all the way bottom to top with glazed tile. But then we find a letter in 1906 from the architects to the Reverend saying like, hey, why don't we take this central column out? It will give more openness and it would be equally strong. I don't think this was the idea of the architect. I very much think that this was Guastavino, who very well understood, having seen, for example, La Lonja and knowing all these staircases, that this central column was not necessary. And the smart businessman as he was, he probably suggested it and then made them think that this was their idea and said, well, you know, like, now I have to do more work because like there's no central support anymore, which it's not more work, right? It's less work. You're taking out this big column. You're not putting the fancy tiles on it. So he was like, oh, But so I'll do that for you because you want it. And then I won't put the tiles on the bottom part of the crib because no one's going to see it. And so it was a smart way of quickly making a bit more money. Why could he take out the tiles towards the crypts? Because like the crypts, and this is what we were seeing in the beginning during the construction project photos, is not covered in decorative tiles. So no one sees it. No one comes to the space except, you know, people who take a special tour, and even the people on the special tour don't get to see it unless they ask or I go with my class. So this is now the bottom of the staircase. This is that central column that would otherwise have gone all the way up, but they could save quite a lot of labor and materials by taking out these bricks and the finishing, right? So what is the construction history? So this is on the right here, the section by the architect in 1905. So we know that we have some initial inspectors reports from 1907. Then the drawings are issued on January 27, 1908. Notably, Guastavino Sr. dies 4 days after. So at that point, he was already working at Biltmore, right, in North Carolina. So I'm not sure how involved he was in the planning of this. And I didn't really try figuring it out either. But so most of the construction of the staircase was built in between the period where the cathedral was switching architects. And so we have a letter from 1909 where they say that the Guastavino company is having 50 men on site working on the dome over the crossing and tiling the staircase. So again, right, we talk about the two Guastavinos, and then there's the 50 people who are building this, right? I'd be very interested, like, were those all Spanish immigrants? Like, how many of them came from Valencia? How many other people were that? Like, I find that fascinating. What were they speaking on the job site? English, Spanish, Catalan, like Valencian? Right? So maybe someone has looked in these archives for that information. Fascinates me. In a way, this was built still under the overview of Heinz and Lafarge, the first architects who are rarely credited for the cathedral. But it's like St. Paul's Chapel in a way. I don't think the architects were particularly involved in the staircase. They just said staircase by Guastavino Company and they left it to them. So credit where it's due with the Guastavino Company. Just another close-up photo. I just want to point out here these two layers of tiles, or it appears that there's 2 layers of tiles here. This is just cosmetic, right? There's one layer of soffit tile here, and there's a little piece of tile to make it look like there's a second one, but that's make-believe. You have the same on that Baker Hall staircase there. They make it seem that it's 3 layers of tile, but all of the soffit tiles are just for the looks in the end, although they function structurally as well. They contribute. So this is interesting when you go to the bottom of the crypt and you look up, you can actually see how this was built, right? So you have the rough tiles. This is the structure of the staircase vault, and then they go underneath it and they put this coat, capa de compresión, when you put it from the top, right? Normally, so they stick it to the bottom and then they essentially press in the tiles, and then they put in this ribbon joint on this. Also note that you use bigger tiles at the bottom for faster construction, and then you need a delicate tiling, so they use a smaller tile afterwards. What's funny is if you go to the southern staircase, there's this little section of vault left that is stuck to the walls, and Derek pointed this out the first time to me. It's because they started constructing the staircase in the wrong direction. Remember that I told you that they were one twirls clockwise, the other counterclockwise. Here they started making one in the wrong direction, but it's nice because it gives us this section and we can see how this was built. So we essentially have 10 centimeters of like 3 rough tiles with mortar, and then a finished tile at the bottom, giving us a total thickness of about 13 centimeters for this staircase. And what's also nice all the way at the bottom is that you can see how they started building this. And so again, the story of like, we don't do this with formwork is not correct here, right? So they used, because they had this central pillar, the masons were smart enough, like, why would we do this, like sticking it to the walls with gypsum mortar? We have no need. We can just put these little guides into the wall and put our tiles on top of it. And in this case, they didn't even bother removing the guides because they knew no one will go down the staircase who will care. I'm quite grateful that they're still there because it really shows, how this is done. Of course, if you go higher up, right, once you remove this central column, you cannot do that any longer. So unfortunately, we don't have records of how it was built in that case, but we can infer it from construction photos on other sites. So again, going back to the First Church of Christ Scientist, you see that gypsum mortar. So here is really, the typical cantilevered built with gypsum mortar. And I think that's what they used as well. And then at the end, they went with their soffit tiles to stick at the bottom. Again, in the Union Club in 1933, they seem to be using the same technique. And then, so once you have the vault, so the spiral, you can just put the stairs on top, right? One interesting little tidbit we found in the archives was the cost of labor. So they said, in 1909, they have people doing a bunch of odd jobs. They're finishing the tile work. 9 people from the Guastavino company are working there. And the masons are earning $5.60 per day. I put this in this inflation calculator, right? It tells you $5.60 is $200 a day, right? 180 euros a day for a mason in 2025 dollars, which I don't think is terrible. But if you actually go to, I asked, there's one ongoing Guastavino project of Maggie and Derek at the 79th Street Boat Basin in New York. And I went to ask the project manager, hey, how much do your masons make? And so they're unionized. And so they make $530 a day. Before everyone here runs to New York and thinks I can make $530 a day as a mason, these are the most skilled ones. They're unionized. They're working on a government project in the most expensive city before taxes and so on. But this was not very poorly. Like, I think back in the day, it was decently paid. It's now still quite decently paid work. It's because there's skill involved, right? And you also have to keep in mind that in New York City, throughout its whole history, skilled labor was always in short supply, and it is still. So anyway, that's for cost of labor. The condition of the staircase, and I'm just putting these photos because in a few spots, there is water infiltration, actually on the, this is on the north staircase, and there are very, very minor damages. And other than these photos, I do not have photos of damages. So this thing is in marvelous condition, but where water got in, at this central dome, we do have some cracking of tiles. We have lost a little bit of railing. There's maybe some chipping on a tile, some water damage, but other than that, it is in excellent shape. So that brings me to the question, how does this thing structurally work? I'm a structural engineer. How does this work, right? And the question is also, why would you bother analyzing this, right? Like, we know they work, but we're dealing with unreinforced masonry, which is not really in the building code anymore. And there's this myth of lack of understanding. So John Oxendorf, in his book, notes that these staircases are not fully understood, and it references 2 other works where no one has really in-depth thought about this. But because he mentions in his book, there's still questions of how this works, there's this myth going around, like if you look on Reddit about this Baker Hall staircase, it says like no one, even MIT PhD students, can figure out how this stands. And it creates this kind of mythicism. And I think that is a bad thing, because say one day a bunch of tiles are falling and no one has studied this, and they go and they say, hey, these tiles are falling, prove me this thing works. And then you go to the authority's book and it says, well, it's not fully not understood, even though I am 100% sure that John Oxendorf knows how these things work, right? You are at risk that like you create, that ignorance is going to cause demolition. And I really don't want that to happen. So why don't we actually spend the time to try to understand that? So that if that emergency, a falling tile arises, we do know how it works. So some earlier work on this were some studies by Caladine and then by Jose Antonio Garcia Ares. The first analysis using membrane theory has some problems and like acknowledges like we need more work. The second one is actually really clever and I think figures this largely out. But again, like the author himself says que quedan aún muchos asuntos en los que profundizar. La solución de equilibrio obtenida considera que el cilindro perimetral solo se la transmiten empujes horizontales radiales. Esta hipótesis es bastante conservadora, lleva a tensiones de compresión considerables. We need to study this more. And since I think that this initial image is hard to read, I'm going to take you step by step, trying to get you to understand this. And so how does this work? If you know the Penguin Pavilion in the London Zoo by Ove Arup, this was kind of a shocker, right? Like this is like a ramp, helical staircase built for penguins in this case, because why not? But so how does this work? This works because there's a ton of steel in it, a ton of reinforcement, right? We are dealing with unreinforced masonry, so not like this. It's very different, but it's the same type of forces you're dealing with. You're dealing with bending, you're dealing with torsion, you're dealing with twisting. You may have wondered, why is this guy walking up with a banana? Well, if you try to hold this banana in like just these two spots, if I don't clamp it in, it wants to rotate this way, right? That's that torsional moment that, right? This is your ramp. This one to twist this way. So something needs to be pushing here, right? And so that's how that staircase is going to work. And so when we think about normally Bóvedas Tabicadas, we think of them as like a set of arches in a simplified way. And we analyze them using truss lines. We consider the material as like, it takes no tension. It has infinite compression strength. There's no sliding between blocks and there's no significant unity formation. And so the theory is that as long as you can fit one equilibrium solution, one truss line in this masonry, that your arch will stand. And so now we need to move from this to this spiraling thing, and I will take you there in steps. So again, the spiraling one looks quite different than this, but if we take our first step and we look at our simplified stairs, right? So now you have my initial arch that I've just cut into two pieces. And here you have a horizontal reaction. At the bottom, you have a horizontal reaction and a vertical one. So as long as you have a wall here or something that this half arch staircase can push against, this thing will stand. I hope you understand how we get from this one to this one. Assuming that's a yes, then we can go another direction, right? So now if we rotate this thing, assume that you have walls here, right, that give you a reaction. So, right, load comes from the top. You need a restraint to the top for this outward thrust of this staircase, this horizontal reaction. You have a reaction in this direction that you need to push at, and you need a vertical reaction to pick up the weight of this guy, or you need to push it into there. If I take the wall away for a second here, you have like a horizontal reaction here, you have another one there. If we move that one more direction, right, and then rather than putting right, two walls, I make that a curve, right? You have at every landing a vertical reaction, and then you have a radial reaction where you're winding down. And so now I have discretized this in like simplified steps, but in reality, my spiraling staircase also has like some curvature in this direction, and it has support all along my spiral, right? So I have support everywhere along this wall, and then we're spiraling down. And so the way in our work we are structurally analyzing this, and I don't want to go into incredible detail here because it's very complex, is that we define a set of linear arches. So rather than, so these become a set of curves that we define analytically. You have a support at the bottom, a support at the top. You assume that every step pushes down on the next one, and then this thread here will want to twist, right? And so in order to make this work in equilibrium, you need to have a pushing force from the wall here that falls within the section of this thread. That's the only way you can come up with an equilibrium solution in compression. What's very important is that you have your boundary conditions at the top and at the bottom, that they can resist the push. The push at the top is not all that great, but at the bottom, there's all the weight of the stairs that needs to be concentrated here, although the surrounding area is picking up some as well. And so at the bottom, we have this pillar and column. At the top, we have the wall and the dome. And so the way that translates is, our Italian professor friend puts in the analytical equations, you split up your dome, and this analysis is preliminary. We need to fine tune a couple of things, but we're pretty sure it works. And so you cut up the staircase into 9 of these linear arches. You have your railing on the interior, which provides a load. So what you put in is you put geometry and material properties, your safe theorem. Then the loading you consider is dead load, the load of the parapet here, live loads. And what comes out of our analysis is our admissible load paths, the reactions and stresses in the steps, and the required reaction forces. I am doing all this knowing fully well that this staircase works, right? Like I have my entire class like squeezed together on it just to prove the point. But my question is, what I want to show in this analysis is, what if I take this whole bottom tile layer off? Does it still work? Because if I can prove that, right? If like Kent is asked to go up and sound with a hammer and he finds that 50% of the tiles are gone, I would love to point and say, hey, my paper shows you that this thing can still stand. No worries, just put the tiles back in a good way. So my output of my analysis is not super important. If you're not an engineer, this doesn't mean much, but what matters is that like the reactions at the top and at the bottom and at the different points of the stair cannot surpass the capacity of my walls, right? So the stair cannot push the wall apart. And when I do the math, the values I get are very low. So it's not a problem. Preliminary numbers, need to do them again. What I want you to take away of how this thing works is much more the concept, right? That you need like these, you need a truss line that fits within the masonry. So the thickness of the masonry matters. You need your reactions from the spiral and from the boundary walls. This is actually what was shown in this this original paper that I mentioned, right? Like he shows an analytical solution where you have the reaction at the top, at the bottom, and a continuous support on the side. So with that, I want to go over my conclusion and main findings. And so this is probably the first real comprehensive analysis of one of these Guastavino staircases. The use of mortar was adjusted based on the needs, on the location of the staircase, and in general in Guastavino vaults, it's nuanced which type of mortar is used in which moment. The Guastavino company, and I think this was published before, but I've given you another example, was really smart in combining craftsmanship, but also being good at business and being smart about advertising, when to charge, building beautiful things, but also doing it in an economically sustainable way. There's remarkable precision in construction here. I could not detect it with our analysis. After 114 years, like there's a little bit of maintenance needed, but nothing has done on this staircase in 114 years, and it's in immaculate condition, except for where there were some leaks. Then I've provided some improved structural understanding and arch action The way this works is through arch action with outward thrust, and so you need a 3D equilibrium solution. There's ample structural capacity here. There's no need for structural concern, as we knew before even starting, and it's probably the most beautiful staircase in New York City, and therefore the world's. A last look of the staircase, and then a final look from below. If you have questions, or if you find yourself in New York, close to Columbia, please reach out, and maybe I can get you in here or show you St. Paul's Chapel in more detail. So. Do we stay for questions?
Bueno, muchas gracias. We're going to make questions at the end.
Okay.
Vamos a hacer ahora un descanso, ¿vale? Tenemos hasta las 7:15. Deciros dos cosas importantes, que después tenemos dos conferencias más finales, ¿no? La de Derek, que le hemos trasladado de tiempo, y la de Ramón Graus. Y que después tenemos un turno de preguntas, y el colegio nos ha preparado un aperitivo para todos luego al final, o sea que quien tenga paciencia al final tendrá un aperitivo. Y luego una cosa importante, yo he visto gente, bueno, que algunas que iba haciendo algunas fotos y algo así, que está muy bien, pero bueno, que sepáis que todo esto se va a traducir en unas actas, igual que el primer simposio, el segundo hubo actas, también va a haber actas en este simposio, y esperemos que sean pronto, porque justo las actas de 2018 nos pilló el COVID por medio, pero ahora esperemos que no haya COVID y salgan pronto las actas. Bien, pues nada, de descanso hasta las 7:15. Venga, nos vemos ahora.
It's now like one of these things that I'm like, I should probably go back and check it, but I think especially so, based on the new building codes at the time of construction, you needed to make walls thicker lower you want. So I'm pretty sure that the top of the wall, we only have maybe about 30 centimeters. And as they go down, so you're saying that's taking the wood. Yes. So what's happening is that you need like so there's stress going down, right? The stress line goes down, but like each you need like equilibrium. So the only way you're gonna get equilibrium in these curves is that something is pushing back. So the wall is essentially pushing every track wants to rotate. So the wall is pushing back equilibrium. Yes.
Exactly. It was just I think it was snow, not just water. But then it was just, I mean, that was why we removed as much tiles.
It's curving. At this point, you have like both because outward down, always inside of the vault.
but because this needs to go around, you always need like a radio reflection. It's really tricky. So we have the thread, using the thread. So you have like your load is going down in like a spiral. If this is your spiral, like you need kind of something pushing back in that direction. So if I have like the load going this way, something needs to push here. So this needs to be restrained here at the top with something else needs to push. Like my thumb needs to push over there. So it doesn't Yes. Yeah. And the thread is also like kind of counterbalancing. Yes. So there's like, if this is a thread, right? Like it's being pushed up by the one below, and it's being pushed by the second. And the thread wants to, let's see this. Here you have like, it looks like this. It's really tricky without going there and seeing it. So, yes, officially at the time we could only train as an architect in Madrid. So he had a degree of Master of Bóvedas, which I think is as close as like the only thing that was missing was like, someone said yes in the architects, another standards, yes in the architects. I think he was much more than what we do today. I know that you guys are architects also doing it, right? That's much more what this guy is also doing, because a lot of architects these days, at least the ones I work with, they just design, but they don't really understand it, right? Like he was a contractor, builder, and like designer. Anyway, that is my life and maybe something that needs to be hi. Thank you. Okay. Yeah. Yes. Nice. Oh, right. Yeah. We have some data. We have like I don't know if I have the project plus data. I did some modeling of these things, and I used the data that I have from Matthew Young, who's PhD in geology. And so I did the material data out there. Yeah, I think we always think that when you analyze this, you assume the zero success rate. Give me one moment, because that's my life. Yeah, that's true. carteles se había pagado. Que tenía el ordenador puesto todo de cada foto, la chapa, la máquina. Es que ese no sé por qué cuando para se queda en negro. Pero estaba misma configuración.
Porque ahora van a hablar en inglés.
Es que igual la pantalla se ha apagado porque aquello se apaga la pantalla y esto no recibe señal.
So you saw it. The work was all done. It's been a really interesting At that time, there was almost no Well, I think this is a great idea, but I don't think he said, really, it's a great idea. That's a quote. It's a great idea, but I don't think anybody thinks, let's do it anyway. That's what he said. I said, okay, we'll do it. We had and then also publish you have it. We heard you go away. There's a lot more now. But still not enough. I mean, within the market. So that's why we look for yeah, exactly. So we're still looking for a standard code. I think we may have found it. I'll find out more. They have a commercial publisher. They give translations. They wouldn't. I don't think they would give us any kind of advice. But it's not as bad. We don't really. Yeah, that's all.
Space that I get, yeah, that I get from within it. So, and I really value it. It's really good, right? Make sure there's a story told. You're not just sort of showing off. No, but it's still. Sometimes presentations are on it, so
It sounded like what he was dealing with was kind of out of his control.
yeah.
You know, and
But it's like I have laptops here and should be able to send a link to download it on server or something. I'm gonna have to figure it out because I'm gonna have the same constraints.
so this guy,
Well, we're gonna
it
be,
wasn't a problem.
yeah, because I could just bring my laptop. Well, we're gonna be at the other school, so instead of 87, so, oh, I'm not surprised.
I heard you talk about moving to Friday.
Yeah. would know that. And then I think there might be like this super defined or something, but I'd rather just say, no, but you're gonna do this.
Oh, it looks like it's here. I mean, there's the titles. Well, it was, basically the school cafeteria, but so it was sort of, I guess you could bring your family along. Trips like this. I did some of that when the kids were little.
Instead, I'm gonna take an hour flight and leave at 6 a.m. and get there. It's a much.
Pretty high on this game.
I skip most. We were trying to adjust it so that it was more like.
Yes. Absolutely, yeah. Tell me your name. Martha? M-A-R-T-A, yeah?
Yeah, that was easy.
My pleasure. My pleasure. It's, well, no, it's very few people ask. And it has nothing to do with my sexuality, my gender bias, or anything else. It means nothing. It's what? It's nail polish. It's just nail polish. My granddaughter painted my nails for me. And she lives in Australia. And I don't see her very often. So I told her I would keep the ring. So now when we see each other in FaceTime or Zoom or whatever, and she says, Opa, like this. So it's very cute. And there's been a little, it's become a little bit more, but I probably don't have the time to tell you, but I'll tell you more later. But not something else. I have a trans child, 40 years old. Who just came out in the hospital, which was a bit of a shock to me and everybody. Nobody had any idea. And we're all very happy for her now. But this is also a reminder because when people see it, you can feel a little like goes up. So what are we dealing with now? You know? So when it's noticed, and you can feel that, and I feel that every day, and that has made me much more empathetic for her, and it makes me more conscious of what she has to do. Mm-hmm. Female. Yeah. Female. Okay. Yeah. And happy. Mm-hmm. Supported. Right. Yeah, that helps a lot. Sadie, who's my son, my daughter, I'm still working on this, you know, is in a much happier frame. So she didn't know, even for all these years, you know, what was going on, and eventually figured it out and said, I have to do this. So we all accepted it. We support her in every way. This is just a little reminder. You're entirely welcome. No, ya no saludaba, ya no saludaba. It's very hard to read. You have to read it. Stay at the top. You can't read it too long. Yeah, you can understand it.
This is set up with the.
Sorry?
Sorry? Is this set up with the presenter mode? I have a little script at the bottom.
I don't know. You can ask Marga.
Is this in presenter mode or is this mirror?
No, pero él tiene una pantalla al lado que que va haciendo es la siguiente pantalla de texto, ¿no? She cannot. Is that a problem? She improvised.
I will improvise.
Okay.
Yeah, I have a script for the front and then
I'm sorry.
no, that's okay.
Bueno, vamos a seguir. Vamos a continuar. Si podéis tomar asiento. Bueno, es otro placer también presentaros a Derek. Creo que nos conocemos también desde hace unos 20 años, subidos a la cúpula de San John de Divine, paseando por allí, por las bóvedas. Derek es un ingeniero estructural en Tillin, que antes era el Robert Stillman Associates, desde el año 2006. Bueno, su experiencia profesional pues, incluye restauraciones, renovaciones, proyectos, digamos, planes directores. Entre los proyectos que han trabajado, pues ya se han comentado, pues la Catedral de San John de Divine, por supuesto, en Nueva York, un plan director y renovación del Fuerte Adams en Newport y, por ejemplo, el estudio previo y el plan de restauración para el Monroe's Placer Mining Company Hanging Flume, que es una especie de canal colgado de madera fascinante en un cañón por donde circulaba el agua para explorar. Es un lugar, flume es una palabra rara específica solo para esos canales colgantes que también lo pasó en grande colgado allí. Bueno, os dejo con Derek y thank you for coming. Go ahead.
Gracias. El meu nom es Derek Trostad, soy un ingeniero a Nueva York y he dedicado casi el del todo a las estructuras históricas. Duolingo. My wife's family is from Barcelona, and I had to try. I had a script. It's not in presenter mode, so I'm going to go improvisational here. I had originally hoped to speak a little bit about an evolution that I had thought I had seen for a brief moment in some work we were doing relatively recently in New York City. And setting up a timer here, sorry. And when I submitted the title for this paper to Fernando, I thought and discussed with my colleague Margaret, who will speak again on Friday. Will speak on Friday. I thought that there was a linear relationship between some of the work that we were doing on some very simple traditional vaults, such as these. These are grossly oversimplified, but at St. Francis de Sales, a church in Philadelphia, Pennsylvania, a very simple dome. Sits on top of a very complicated drum and lower structure, which we'll see a little bit later. The vaults, which you don't see unless you're familiar with Tim or I and other folks who can get you into the basement at the Cathedral St. John of the Divine, or Bower vaults, which line pretty much all of the undercroft. And these relatively simple crossed vaults, which we've seen at some locations here, just referencing Kent Hall, another project we've worked on in New York City, near at Columbia University. So these are I think what Guastavino started with. I think this is where the technology sort of originated, and then it evolved over time. And Margaret will talk a little bit about this later, but these are the much more complex hybrid domed and vault systems that we've worked with most recently at several train stations in the United States. The middle photo is or the middle image is of Ellis Island, where we are currently working. We have not developed and are not working on the Guastavino vault. We're working adjacent to it, so we've extracted this image from a thesis done by one of John Oxendorf's students. So I had this idea, and so I went back and I looked at all of the projects that we had done over the years, and Margaret, you'll notice that there's one missing here. So we have 41 projects that we've done since 1966, when Bob Silman founded the company, which is actually now called T.Y. Lin. As you can see at the bottom, I sent Fernando an older biography and neglected to change that. And as I started to consider what I was doing and how these things fit in, and starting to look at the dates of construction of the various buildings, I realized that there really wasn't necessarily an evolution. It may be out there, but it's going to require a little bit more research to find it. There are some obvious things that evolved with the company. They patented their process, including reinforcement. This is not a reinforcement necessarily patent, but it was one that just came readily to hand, and the reinforcement patent will show up later in the presentation. The other was the opening of the La Ceramica in Woburn, Mass, which allowed them greater control over the quality of the product that they produced and the variety of the project that they produced. And lastly was there's one more in the script, but just working from here, was the introduction of graphic statics, which occurred in New York at St. Paul's Chapel, here shown on the right. So there are some changes that have happened in the company, and they're sort of obvious and have been discussed, I think, pretty extensively by others. I went back to the list and I started to look at things that were old and that I didn't know much about, and that people who had done the work were no longer here. And again, you know, it didn't help. It didn't help my case at all. There's just a lot of stuff out there, and there's a lot of variability in what we've seen. This is the structure, and this is a little SketchUp model done in the X-ray mode of the structure that really was the sort of inspiration to me for sort of talking about an evolution. It's the East 54th Street Bath and Gymnasium in New York, built in 1911. It's got a structure in it which we've seen sort of before in other baths. We worked on the bath at Carmine Street, and I'll speak a little bit more about that later. And we worked on the public bath at West 134th Street. We had drawings for one of these structures, the one at West 134th Street. And during the pandemic, there was an emergency at the Carmine Street bath, and we had to go crawl around with masks in very small spaces to sort of understand what was going on with that structure. It was very much a traditional structure. It had a ring around the perimeter to resist thrust from the vaults. It had a fairly simple ovoid vault or ellipsoidal vault. And then it was knee walls above and more Guastavino that was flat on top of that. So very, very traditional structure. We haven't been in the West 134th Street structure, but in the structure we've looked at it, we've done some design work at it, but we haven't gone through the dome to look at what exists between the roof and the dome. But it seems to be, from the drawings we have for that structure, to be very traditional. This one has a very strange hybrid structure that seemed to be somewhere between the traditional structures that I started showing at the beginning and the structures that were in those more complex train station images that Margaret will talk about on Friday. And I looked at it, and it doesn't, it doesn't fall chronologically in the right order. So, what I've kind of concluded here out of that is that I forgot a Y here. Is that there wasn't an evolution. There was just a certain amount of creative responsiveness that Guastavinos had in dealing with their commissions. They were contacted by architects and asked to do work. As Tim had spoken about before, to a certain extent, I think they were quite happy to be left alone to design what it is that they needed to design. The stair at St. John of the Divine, for example, he just made it up and did something that was quite elegant. So what I want to talk about instead is some work we've done on some of their domes. And I threw this up here just to kind of talk about which ones. The one here in gray is the Madison Square Presbyterian Church, which was sadly the only building, as far as I know, that has been demolished in this image. And then the other three that I want to talk about are in green, San Francisco de Sales in Philadelphia, which I previously mentioned, St. John the Divine, and the dome at the Crossing in blue, and the dome at the Gould Memorial Library at New York University, which is now part of the City University system in New York, and known as Bronx Community College, still Gould Memorial Library. The one in purple on the lower left is the John Germain Memorial Library in Sag Harbor. And I'm going to segue here into sort of a little bit of a preface to what my main feature is. The other thing I just need to tell you too is that the format of this presentation is going to change. About 45 minutes before I was supposed to arrive, I dumped my slide carousel on the floor. This is not a slide carousel, but I erased the end of my presentation and had to reconstruct it. So it gets a little bit, gets a little rougher towards the end. Anyway, one of the things we've seen with buildings, domes in particular, but other structures as well that are similar to domes, where the roof particularly is exposed to weather, is significant deterioration. The first project I'm going to talk about, the St. Francis de Sales, is a dome that was clad with a waterproofing over top of the structural tile. It's exposed on the interior as well with decorative tile, and then there was a 1.25 inch, 1.5 inch thick, relatively lightweight ceramic tile applied to the outside, and it started to fail 40 years after it was built, leaking, failure of the tile. And I think, it's fairly clear if you just look here at the sort of average precipitation that occurs in Barcelona and New York City, there's a significant change. There's more than 2 times as many days of foul weather, rain, particularly. Temperatures in Barcelona are typically warmer than they are in New York. Even though we've got a close average for both cities, we do have lower temperatures and we have snow. So there are freezing temperatures. Same happens in Philadelphia. It's a little warmer there, but it's not quite as warm as Barcelona. So there's, obviously some issues that are happening with the way those structures behave. And so there are 2 things I was kind of trying to explore here. And one is this sort of the appropriateness of the technology transfer from Barcelona and the northeast of Spain to the northeast of the United States, and whether they were responsive in that regard in terms of the climate and how that affected the performance of the structures. Obviously, it works well in a northeastern Spain. I have seen some of the interior of the structure, the Hospital de Santa Creu in St. Pau in Barcelona. I was recently in Sevilla, and as I was driving in the taxi from the train station to my hotel, saw the Teatro Lope de Vega and was unable to get in, but took some photos from the outside. I do not know whether this is a vaulted structure or not, and would be delighted to hear more from folks later about that. And in the U.S., there are some structures. We have not worked on the Museum of Man, but in San Diego, California, the climate is much drier and much more similar to that in Barcelona. We have done work at St. Bartholomew's Church in New York, and here the cladding was a mix of stone, as in the ribs here, and stone and tile on the vaults themselves. So there are cases where it does work, and those and the works that I will examine here shortly bear further examination in terms of what exactly caused the failure. Was it the transfer of the technology and the application of an assembly that didn't work, or was it just simply the technology for waterproofing that was available in the early 20th century that was the problem? This is the assembly. Guastavino was, rightfully proud of their work on these domes. The advertisement that showed the 15 domes that they had built in the early part of the 20th century, late part of the 19th century. I think there was one from 1899, and then the rest very early in the 20th century. It was a remarkable feat on their part. They wanted to sell this and convince more people to do that. I think they did. There are quite a few more domes that are out there. And this provided a kind of advertisement, provided a very succinct summary of what it is that those assemblies were, and a good guide to architects. But again, the detail on the right shows the assembly, some structure, the decorative tile or finished tiling, and entire interior, some structural tile. In this case, on the left, a hollow tile that sort of helps thermal performance. I have not seen that. The only building I know of that has that is the Buell Auditorium in Pittsburgh, Pennsylvania, and then another waterproofing and some additional material over the top. We haven't seen many failures that are abject failures like this one. This is a receiving mausoleum, a receiving vault in a cemetery north of Philadelphia, similar location to where St. Francis de Sales, the church that I'll speak to later, exists. The assembly is very much similar to what was shown on the ad in the previous photo. You can see there's a detail. I don't know if you can see right here. There's a little detail that's very similar to what was shown in the advertisement, and the assembly is the same. But this is the condition of it when I first saw it. I drove up. It's in the records in the Avery Archive, the Guastavino Archive at Avery Library, as being in New York. But I poked around on Google Maps and was able to actually find it in a suburb north of Philadelphia. But this is how it looked when I first got there. It had been abandoned because a receiving vault these days is with mechanical refrigeration and mechanical backhoes for excavation of the soil, no longer necessary in cold months. And this had fallen into great disrepair. On a subsequent visit with Kent Diebold, they had actually given this thing a haircut, and all the trees were gone, and you could walk up to it and see it. I thought these were a little bit more dramatic, especially with this turkey vulture in the corner. Anyways, this failed. This was not a failure from excess stress or overload. This was a failure because of some things that I think were details that were developed by Guastavino in the execution of these works. The waterproofing and the tile finishes, perhaps, and again needs more exploration. The other structure here where we've seen a failure, but it was a limited failure, was at the John Germain Memorial Library on the eastern end of Long Island. Here, the library was undergoing a major expansion project that included work on the dome, restoration of the dome. The copper cladding on this had never been replaced. They were cleaning and pointing and replacing the roof to just ensure that they had a sound and healthy library in toto at the completion of the expansion. As the roof came off, they discovered this problem here. The tension rod at the exterior of the main vault, which is up in here, had fractured. This is completely broken all the way through. There was sufficient redundancy in the way that the structure was built that there were zero signs of any structural stress. There were no cracks, displacement, or anything. We managed to save this, temporarily restrain the vault with a circular shoring system, and then incrementally replacing the tension hoop. So this is a success story. To sort of bolster my thesis, so to speak, this is a building we have not worked on. It's the Elephant House at the Bronx Zoo, now the Wildlife Conservation Society, still in the Bronx. And this building had a beautiful decorative ceramic tile roof, and they had major work 3 times between when its original construction in 1908 and 1925. In the upper left, there is a very faint detail, sorry for that quality, but that's what is available from the Wildlife Conservation Society, indicating that the lower portion of the roof was to be removed and replaced, and waterproofing reestablished. There is another detail that I didn't want to fit on the page here, or just couldn't logically fit on the page. It shows exactly what they're doing, but just basically removing everything below this line, replacing it, waterproofing, and so forth. Not very many years after that, 10 years or so, all of this material was either removed or replaced or covered by this batten seam copper roof. So there are issues, and it's not clear whether that's a material issue. It's not clear whether that's a waterproofing issue, but it's certainly something that this guy wants us to think about. And then this last one is kind of a sad story. During COVID, we were right before COVID, we were working on this building, and during COVID, they discovered, because they had some portions of the structure open that were exposing it to water, they were allowed to continue work as an essential work. They discovered that the crack that was in the ceiling of the very large vault here, another elliptical vault, which you can barely see in these drawings here, but there's an elliptical vault here, had a crack in it, and the crack was there because the tension component at the rear of the building had fractured. These are photos. I was really lucky enough to go up into that space and look at this. It's pretty tight up in here, but completely broken at the backside of the structure. So that again was shored. We developed a nice repair program for that, put it out to bid. And unfortunately, the city now thinks it would be more cost effective to demolish the building and sell the property to a developer. So there may be more losses here. So we have a background of concern about this, and then there's what I want to sort of segue to here, but we'll take another quick sidebar. I hope to speak to just some of the work that we do to just make sure that we're doing the smart thing to get this to get these domes and other structures repaired correctly. Is to sort of speak about the evolution of how we respond to and treat these structures. So this is, I think, where I dump my slide tray. We do test. We test a lot. We test for material properties. Margaret will speak to sort of the material properties that we need later this week when we're doing these much more complex hybrid structures. But we'd like compressive strength. We like Poisson's ratio so we can understand the stiffness of the structure. We take mortar samples. We work with architects and architectural conservators a lot. They very frequently like to take many samples of the pointing mortar. They don't so often like to take samples of other mortars. There's a setting mortar, the gypsum that has been mentioned previously, and then the what we call the bedding mortar, which is the mortar that sits between that first course of tile and the subsequent courses of tile, which tends to be a hard Portland cement based material. Typically, we take cores, as in the center slide, and then other instances where we have to work overhead, we often take larger prismatic structures out of the vaults so that we can then remove the cores without having to have water dripping down onto the coring machine. This in the middle is a core that was taken from the Gold Memorial Library, which we'll talk about more later. This funny looking tile on the outside here is a nailable tile. Clever, and allowed direct application of some copper shingles to the top of this dome, but ultimately not so good. We also do non-destructive evaluation. We want to know whether the vaults are reinforced. There are not that many that we found that are reinforced. We found some reinforcing at the Oyster Bar in Grand Central, which we had not anticipated. There had been a prior study by our office that did not anticipate that, and we had worked on it, I think, 15 years prior when there had been an enormous fire at the kitchen of the Oyster Bar, and there had been no documentation of any reinforcement at that time. So that was a bit of a surprise. We have found it on a few other projects, including one I'll speak about later, and at the Crossing Dome at St. John of Divine, which I'll also speak about later. And then lastly, everybody does laser surveys these days because it's sort of an essential part of what we do to measure buildings to understand what's there, to not have to go out with tapes and pencils and paper and measure things. Frequently, those documents, that data gets converted into a not very good Revit model of these complex curve structures, which is somewhat frustrating. We've started to work with a firm that does a lot of work in Rhino and can actually depict some of the forms that we need much more accurately, and we get them to do these differences maps, which allow us to understand what the vault actually looks like. In this case, a project I won't talk about much more than just in this slide is a library at Columbia University that had a plaster ceiling, and plaster ceiling was kind of an incredible structure in and of itself. It was precast modular and adhered to the Guastavino directly with plaster wads, which are plaster and a fibrous material, but burlap typically, that's thrown up against the Guastavino, and then the tile, plaster tile, are then pressed into that. In this case, the university wanted to put in a fire protection system, a sprinkler, and then they didn't. And then they said, go away to us, and we went away, and we came back 3 months later and they installed a fire protection system. And I think the day before they called us back into the building, the librarians had walked into and seen what had been done to their ceiling, which was absolutely marvelous, and said, no, you have to fix that. They had installed all the fire sprinkler systems just wherever was convenient for the pipe fitter, using pieces of pipe that were this long with joints everywhere. It was a mess. So the facilities folks came back to us and said, how do we hide this? This is a funny structure. What we see here is in color is all Guastavino. There's also Guastavino here and Guastavino here, which was not mapped because it was covered when these spaces were converted at some point in the 1930s to include some mezzanine spaces for additional office and storage space. You can see these vaults that correspond here. These areas here are at the ceiling level, concrete slabs. At the floor level above this, which is actually square or rectangular, it's all Guastavino. So there are knee walls that sit above this vault, and then there are knee walls that sit above the concrete slabs that support more Guastavino that are the floor surface above. Anyways, it was critical here for us to understand what level of precision was used in the construction of this vault. And as you can see from the color here, there's a 4-inch, I think it's a 4-inch range between up and down in this vault. There's a gap of about 3 inches between the ceiling and the Guastavino, and it was critical to understand how much room we actually had throughout the whole space to fit the pipe in, which was primarily about 1.5 inches in diameter. This was a very, very critical piece of making sure that we did not run into, or will not in, this is starting construction this fall, clashes with the pipe installation. All right, so now we're going to get into the meat of things. I presented this work in 2012 at a similar conference in MIT. Slightly different focus here because I'm trying to understand what happened. This is St. Francis de Sales in Philadelphia. On the left, I don't know the date of this photograph, but it seems to be shortly after the building was completed. You can see the decorative tile on the domes here, and there's another dome down through here, and the main dome in the center. 2 domes here, and a center dome. On the right, there's a dome, a photo of the domes at the side street have been repaired with a tile that's cleaner, whiter, and brighter, and the dome is the same. The photo in the middle is what was the result, is the finished product of what was done to it in the 1950s. It shows a very bright white glazed, very thin tile, sort of 1 centimeter thick or less. This is originally designed and constructed in 1909. There were 4 tension hoops in the building. You can sort of see the bumps here with the arrows, and then the tension. I've added the color here to identify it. This it's hard to see because I put a red line over it, but this is the uppermost hoop, and that was starting to show indications of a brown color or discoloration on this black and white photograph, which suggests that there was some deterioration occurring at that location. There's a piece. Ooh, look at that. I didn't do that on purpose. This detail on the left shows a pencil sketch to sort of explain what needed to be done at the location of the uppermost ring, which is here, to conceal this. It's very thin tile cover and presumably waterproofing that covered that hoop. That's the hoop that on the previous slide was colored red. This is a core taken through the vault, almost all the way through the vault. We've got structural tile at the bottom, which is the primary structure we did not go through, and so there's another layer of tile below this that was exposed on the interior. And this buff yellow colored tile here is the thicker tile that was originally exposed. There was a waterproofing membrane and so forth in here, which did not survive the extraction process. They did, in the 1950s, install a waterproofing membrane concrete that was reinforced with a metal lath. And then they put this very thin ceramic tile at the very top. This is 2 photographs of the execution of that work, this prep work that's now occurred on the vault, and the concrete will be installed over this waterproofing membrane. I include this and want to discuss this because it's an example of what not to do. I mean, it was done at several locations at the St. Louis Art Museum. There was concrete applied all over the vaults. At the Metropolitan Museum of Art in New York City, people in the 1950s and into the 1960s really didn't understand what they were looking at in some of the galleries, and they ended up demolishing what would at the end of the day would have been perfectly viable structure to support the proposed change from 150 to 300 pounds of live load. So bad treatment of the building is sort of this example. Our treatment here, I was really an advocate for removing the concrete that was applied because it's just as insulting. As is often the case with many of our clients, there's a limited amount of money, and there was no appetite for doing that. They didn't have the money, and they pushed us for an alternate solution. The concrete here was tested and it was remarkably impermeable. Usually not a great thing for concrete that's exposed to the exterior, where you want a little bit of air entrainment just to improve performance. But given the sloped surface and the fact that water ponding was not going to be a problem here, we opted to remove the tile, which was removed in advance of the design phase of the project because it was sheeting off. You can see where the arrows are on the left, that large pieces were coming off and falling to the street. So ultimately, that surface was cleaned, tidied up with some patching compounds, and then coated with a silicate paint, which in this photograph looks pretty nice. Tried to adhere to the architect and manage this work. We did not have anything really to do with this part of it, and it looked pretty nice at the end of the project. Unfortunately, it faded pretty dramatically, and inside of a year, it had all kind of gone to white, which was unfortunate. Anyways, we'll move to another project. This is McKim Eaton White project. It's a little bit more complicated than St. Francis Sales. Actually had very complicated structure below the pendentives. That's a subject for another talk. At the Gould Memorial Library at what was the New York University campus in the Bronx, the dome is a little simpler. It sits on a masonry drum, sitting on some steel structure, and clad with copper shingles. There was and there still is actually quite a lot of Guastavino in this building. This area here is a terrace that was behind the building and was later extended to become part of the Hall of Fame, which is a long linear structure other than where it curves here, that is all Guastavino vaults. And then the area here was all Guastavino below. You can start to see a section here. You can see the Guastavino vaults up above. Here, the Guastavino vaults here across the back and in these spaces. All of this material here in that terrace was Guastavino vaulting. Here, this is an open space between the building and the terrace. And an example of what that structure was. That was all removed and replaced with new steel and concrete at some point in the 1990s. I don't know whether we did that work. We have had prior involvement on this project, but on this building, but I have been unable to find evidence that we did that. Bad treatment of the building in that location. Again, waterproofing issues. Presumably there was a promenade tile structure, which is frequently used on roofs throughout New York City on buildings from the early 20th century. That typically performs very well. That is a built-up assembly similar to what was shown on that advertisement for the dome roofing. I included this because I actually had another image that I wanted to include that was a Guastavino vault, but there were some back and forth here with the Guastavino company about what the vault was going to look like. Ultimately, this is what McKim Eden White proposed. This is another iteration of McKim Eden White's version of what was happening. This Guastavino was not installed. This is actually just a steel frame structure down in here, but the structure was revised from a fairly simple single shell of a vault with a plaster ceiling applied to a very tightly spaced double vault. There's some slides of that, upcoming slides, and a perimeter tunnel to form these steps. This is a quick view of the structure. This is a strange sort of reflected ceiling plan here for the dome, and then a plan of the roofing around the perimeter, and then the structure that supports the drum, which ultimately supports the dome. A lot of this work was started because the roof was leaking, and there was a pretty profound bow in this masonry wall around the perimeter of the building, and there was concern about the integrity of the tension hoop that was down low inside this building. You can see the separation that's occurred here is pretty profound. We did some testing and some probes that included, because we couldn't get all the way around, there was a lot of concern about what was happening at the very bulged portion of the structure, to test for continuity in this ring, and found no issues with that as we got into the project and removed the brick and no longer were concerned about the safety of that wall collapsing down onto the campus quad. We opened up some larger holes and were able to see also that the steel was in good shape. There's a second tension ring that was up at the top of the vault that surrounds the tunnel, which we found was in not so hot shape, and that was repaired incrementally here. Again, some of those holes where bolts were never installed were filled with appropriate bolts. This is the vault assembly. This is the interior plaster on the left, and then strangely in this tunnel, there are radiators that heat this tunnel, and then there are holes in the vault. You can see here on the left where the Guastavino has been removed, the backside of a wad and the ceiling around it that's on the other side. These holes, I think there are 12 of these around the perimeter, enter into the space between the outer vault, to which this is within the tunnel, but as this vault continues up, this is where the roofing is nailed, and the lower vault, which supports the ceiling. Separation occurs all the way to the oculus at the top of the dome. Two photos that sort of show the compound. There's a pier that exists between the two of them at the top. This is the structure for the cupola at the top, weirdly sited over a hole and not over a pier. Leaking within that space, the right active water leaks at the time when we were doing surveying. This is me in there just to show some indication of the size of that space, but also because this hole in the top allows us to look up into the steps above the tunnel. The tension hoop that we were seeing previously was here. The tension hoop for the main vault is way down there. We saw those photos in a prior slide. Anyways, this is what the shingles were on the outside. Perhaps more water resistant than the ceramic tile finishes. very similar assembly to a certain extent, not as much coal tar or asphalt, much more light impregnated felt below these, and almost no lap. This has just been folded up and then folded back down and screwed back down. There's just a very simple lap there. This building leaked since the day it was completed. So our mandate here was to replace those tiles and to try and figure out a way to do that without affecting the basic appearance of the structure. We went back and forth with a bunch of different approaches. What was ultimately built here was something that the contractor suggested based on the design that we had provided in the construction documents. That is a plate that's secured to the vault surface with a screw that's countersunk into this hole, and then bars. You can see the bars down here below that fit into this space. A couple nice photographs of how that got installed, to which the shingles were then attached. This is some room to allow those bars, these armor. We call this an armature, but this is a simple bar that's attached at regular intervals. This is a mock-up to show the viability of this. In later installation, this was a recessed anchor, and none of this stuff stuck up above the top of the plate. This is the start of the work. They install these plates below to sort of separate and allow the roofing to move on top of the Guastavino. The entire dome was covered with an EPDM membrane that was there for temporary protection during construction, so that the vault could stay dry and in fact dry out a little bit during construction. And then the armature was installed over the top of that. Here, as they continue to install the shingles, shown here, connected to the armature with a clip and soldered. This was taken apart at one point, but then also soldered shingle to shingle. There was another layer of EPDM that was lapped over the top of those connections. I'm going to run out of time here, but I'll just keep powering through. Anyways, here I am again. This is a final photo. It actually worked out quite well. Kept us quite busy during COVID, which was really nice. Outside, I could drive there in 10 minutes. Normally a trip that took over an hour on the subway. And then St. John of the Vine. This is, a temporary structure that had been around for 120 years before the cathedral finally decided that it's still temporary. They're going to build a 200-foot tower here someday, but it's not in my lifetime, and probably not in most people's lifetimes. And that they needed to stop the water that was coming in here. Every time it rained, there was a crew of folks who went out with gigantic blue buckets to sit on the crossing floor to catch the water that came through this structure. We started this project with this is during construction, obviously, but Guastavino drawing of the dome. We did do some structural analysis here to confirm that the dome had capacity to support what we did, which was add a stainless steel framing over the top and copper roofing. Interior photo looking up. Access to the vault into the dome here is extraordinarily difficult. There is no lift that can make it into the door of the cathedral and reach the apex of the vault of the dome. What you can see here, these little tiny dots all over this photograph are actually pieces of tape. And this is the limit of what we can reach from a lift that fits into the structure. Each of these, there's 2 or 3 different colored pieces of tape that were applied to this through a netting that was applied in the 1970s over the surface of the dome that indicates some failure of the tile at that location. We started a testing program and probe program that's sort of depicted to a certain extent on the right. We opened up a bunch of holes around the perimeter of the dome as it touched the supporting granite arches to understand what was happening with the dome as it touched that. On the interior, there's a separation along the intrados at the interior face of the wall of the arch that had a lot of people concerned. You could see that from here, couldn't touch it, couldn't look at it. couldn't get to it. Very tight all the way around the perimeter. We had done San Francisco sales previously, and there were clearly issues with corrosion of the tension ring there. And this thing had been leaking, had temporary waterproofing on it, had roofing installed on it in the 1970s that we were concerned was holding water into the structure. And so we created these long strips, probes, so that we could start to see the top surface of the Guastavino and all of the original tension hoop. There was one at this location, and then the subsequent ones were added below. There were 3. This had a very lumpy surface, which we'll see in the next slide. This is sort of what it looked like. Looking up the vault and then down the vault, there were tension rings that were added, big concrete blocks added on top of the granite arches to constrain those additional tension components. We assumed something in here had to be rusty. It wasn't, including this piece here that was holding the ends of the tension rods on the arches. You can see the assembly. This is the step on the arch, and then on the right, we've got roofing that was applied over foam glass, which is a product, insulation product that was produced in the middle of the 20th century. Still available, I think, but we didn't use it again here. Long vertical probe here, cut in so we could look at the condition of the vault and the tension hoops. This one, a concrete encased bar and turnbuckles. And here, a probe that was one of the few probes that was made into the base of the vault at the dome at the crossing. Very tight, no gap there at all. We proposed this roof because it made sense to a certain extent. We had done some roofing on the apse a number of years earlier, which is not visible from the interior, and had punched through that and created a bunch of spalls on the interior, which were a concern to the owner. They did not want us to use mechanical anchors at the top of the vault, where the thickness is I think on the order of 3 inches. So we did a test. We did a pretty comprehensive test of adhered anchors using various stainless steel clips, as we call them, some perforated, some larger footprint, some narrower, to establish a design capacity for stainless steel clips epoxied to the top of the dome, and use those. This is excerpts from the report that was done by the consultant we hired to do that. This is what we were starting to find on the exterior. As construction started, we had anticipated that we would find some corrosion in some of these tension hoops. There was some well adhered corrosion on pretty much all of them, but there was no deterioration and no need for repair, which was remarkable given how wet this structure had been. We did ultimately replace almost all the concrete around the original tension hoop. It was really poorly consolidated, and as soon as anybody stepped on it, it started to fall off the building. So that was incrementally replaced as we exposed it. There are a number of cracks, circumferential cracks in the dome. One long one here on the north side, and a couple of shorter ones here, and a few others around here on the south side. And this gap that existed between the dome and the supporting arches. And this is a diagram of where those cracks are and the installation of crack monitors that were installed as part of the project. We've been monitoring it for a number of years, and there don't seem to be any issues. Sorry, that was to show you where the cracks are, and then we're going to segue into looking at the cracks from the outside. Vertical access helped with this part of the project. We were able to drill a bunch of core holes through the vault carefully, include several small ones and one very large one that facilitated access to a point on the vault that was much higher than we could get to from a lift. This is the crack pretty sizable. You can fit your fingers into that crack on the north side. And poking at it here from the outside, this may be a south side crack, which is much smaller. Photos from vertical axis report this crack had existed in the 1970s when they were up and installed this net. They had put a mesh reinforced polymer repair over the top of it and then painted it to look like Guastavino. I'm over time here and I'm almost done. We drilled a very large core through so we could catch the geometry of the crack as it continued through the vault, and better understand what we could do. We ultimately ended up grouting this. I had some fantastic photos of grouting that got lost here when I dropped my slide carousel. But anyways, we were able to grout this fairly effectively. We did, unfortunately, leak on the inside. There had been no plan to do any work on the interior of the building, but that changed. There had been a number of fires, and access to that had been limited because of its height. But the cathedral ultimately prevailed on their insurance carrier to ante up to scaffold that and allow us access to the interior. So we were able to clean that and touch the interior of the vault as well. This is the assembly that we devised for the exterior, which again clips here that are attached lower down with mechanical fasteners, and then the stainless steel light gauge steel framing that ran over and in some of the cases covered over the topography created by the supplemental restraints. All of this was then sprayed with an insulation to meet energy code, and then also to help limit the thermal stress on the structure. Here's the cracks. Here's the response. It's a little varied. We haven't looked at it too carefully. We had some issues with that monitoring, and now have gotten that sorted out. We were collecting data every 10 minutes, and the data overwhelmed Excel, and we had to develop another program to develop another way to process that data. Anyways, this is the finished quality of that. I'm over time, and I could talk about this, but I think I can stop here. I think Margaret may talk about this a little bit more later. This is the West 79th Street. Here's Margaret crawling through it. This is a sad story. Ultimately, the contractor on this was given the option to repair, and we had prepared documents to repair it. Had done a lot of study of this. It was salt saturated and an utter mess from the perspective of testing, but in absolutely phenomenal condition. The contractor ultimately opted to do replacement rather than repair. One way or the other, there were a lot of holes in this, and there were going to be areas that probably were going to be replaced. So the contractor was obligated to do a mock-up. They did a phenomenal job. They did use a lot of formwork here. We showed them that they didn't have to use that, but they did, and are busy working on that. We, again, not a great response, but we were able to sort of evolve. We have had experiences here with delamination of tile and the way that it was fabricated. At lunch today, Fernando mentioned the red tile that Guastavino used when he first got to the US and sort of rejected it. We've tried to improve on that by installation by fabricating the tile with a much rougher surface, mechanically imposed keying. A couple of photos of the mock-up. The masons did a phenomenal job, and now we're done. This is me taking a phone call on the top of a vault that Margaret will speak about on Friday. Thank you. Sorry that was kind of ad hoc. I appreciate your time.
Muchas gracias. Bueno, ya llegamos a la última charla de hoy. Es otro buen amigo. Ya son como 20 años que nos conocemos desde que nos invitó a trabajar en Revimed, hace unos 20 años también. Bueno, Ramón Graus es profesor de la Universidad Politécnica de Valencia, doctor arquitecto, es profesor agregado de Historia, Arquitectura y Construcción en la Universidad Politécnica de Cataluña. Y, por cierto, Camila, ahí está un libro que quería enseñarlo. Ha publicado el libro El recinto de la Escuela Industrial de Barcelona y ha comisionado la exposición Guastavino, Rubio y Baldric, arquitectos de la Escuela Industrial, ambos de la Diputación de Barcelona. Es este libro de aquí, que yo considero entre los mejores libros que he leído de Guastavino, porque al final lo que debo confesar aquí es que tengo una gran admiración por vuestro trabajo, por todo lo que hacéis, por la investigación. Cuando hay una investigación que firma Ramón Graus, hay que estar atento porque es súper buena. Siempre si se meten lo hacen muy bien.
Bueno, pues muchas gracias por invitarme y por lo que has contado, Fernando. Vamos a ir rápidos. Yo os vengo a hablar de una obra que Guastavino hace con 26 años. Pensemos cuando teníamos 26 años, dónde estábamos, y pensemos el mérito que tiene lo que va a hacer él. Es la fábrica Batlló. La voy a explicar desde el contexto histórico, es decir, lo que hay antes y lo que viene después de esta fábrica. Veis que es en esta factura, esto es una cabecera de factura, dice fábrica de Batlló y Batlló, sucesores de Batlló hermanos. Quien encarga la fábrica son Batlló hermanos, que son 3 hermanos, pero uno se muere, pero el otro está casado con una hija del otro, de manera que cuando inauguran la fábrica, los 2 socios que quedan, que es Feliu Batlló y Joan Batlló, se pelean porque Feliu tiene todas las acciones, Joan se va a montar la fábrica que está en Sants, que se llama Fábrica Batlló, ¿sí? ¿No se oye? Sí, sí. Y se quedan los hijos, que como está casado con una de la familia, son Enric Batlló y familia. Vamos a ver cómo funciona esta fábrica. Esta fábrica son 4 manzanas del ensanche. El edificio alto es la hilandería, el edificio subterráneo es la sala de telares. La sala de telares está a eje de la calle Córcega, de una de las calles de Barcelona. El eje de la hilandería coincide con el eje de la gran chimenea de 63 metros de alto. El acceso principal se produce entre la hilandería y la sala de telares, aunque hay un acceso secundario a eje de la calle transversal por el otro lado. Yo os voy a hablar de 3 cosas. La primera es de las bóvedas de la hilandería, ¿sí? Son estas bóvedas de cañón rebajado sobre vigas de madera que descansan sobre pilares de hierro colado. ¿Esto de dónde viene? A ver, la tradición de la construcción, la arquitectura industrial catalana, en 1820 se construía de esta manera, esta es la fábrica de los paños en Manresa. Pilares de ladrillo, jácenas de madera, vigas de madera y bovedilla, revoltó que decimos. ¿Cuándo entran las grandes bóvedas? En el vapor vell de Sants. Vapor vell de Sants 1845. ¿Por qué? Porque quien funda el vapor vell de Sants es Joan Güell, el padre de Eusebi Güell, conectado con Inglaterra. ¿Qué es lo que vemos aquí? Vemos unas vigas de madera separadas unos 3,40 metros, más o menos así, con una bóveda tabicada. Aquí las veis que además las vigas de madera tienen un postensado, ¿sí? Pero ¿de dónde viene esta preocupación? Esta preocupación viene de Inglaterra. La preocupación que hay de que las fábricas inglesas se queman muy habitualmente por varias razones, pero porque se usaba entarimados de madera, había material inflamable, habría ludismo, ¿no? Lo que lleva es que lo que vale más dinero de construir una fábrica es la póliza de seguros casi. Y por tanto, en la tradición inglesa, por ejemplo, William Stratt, que se les acaba de incendiar una fábrica, William Stratt es un ingeniero mecánico, el que diseña máquinas y repara máquinas. Bueno, dice, vamos a construir, por ejemplo, en Milford, un almacén en el cual, si veis, el pilar de madera se ha sustituido por un pilar de hierro colado, la viga de madera sigue estando, pero el entarimado de madera se ha sustituido por una rosca de ladrillo, una bóveda de rosca de ladrillo. y se ha revestido de yeso la parte inferior de la madera. O sea, hay una voluntad de construir fábricas incombustibles. Esta tradición llegará al vapor Vell de Sants y donde, veis aquí, hay tres crujías, tenemos la misma solución, pero ahora la vamos a comparar, ¿sí? Más o menos es lo mismo, pero donde había una bóveda de rosca, el maestro de obras catalán dice, aquí pongo una bóveda tabicada de las que hacemos normalmente. Y por lo tanto, hay una transferencia tecnológica de la idea de construir fábricas incombustibles y hay una adaptación tecnológica al contexto local. El contexto local no lo entiende todo porque el maestro de obras simplifica la situación y dispone la zapata de metálica que recibe las vigas y pone por encima de las vigas, apoyando directamente contra las vigas, el pilar superior sin mantener la continuidad inglesa, cosa que da muchos problemas. En todo caso, esto es lo que Guastavino recibe en 1868, esta tradición, y la aplica sin demasiadas transformaciones en el edificio de la hilandería, es decir, bóvedas tabicadas sobre vigas de madera, igual como el vapor Vell de Sants. Aquí, en principio, no ha inventado nada. Lo que sí, este es el único plano que tengo de la sección constructiva, es el plano de la rehabilitación que hizo Margarit Bouchade, que encamisó el pilar metálico, pero se ve perfectamente aquí cómo el pilar original tiene continuidad, de manera que Guastavino ya sabe lo que está haciendo. Bien, si nos miramos el contrato de obra, el contrato dice, en los pisos se emplearán bóvedas tabicadas de dos gruesos, uno de baldosa, lo que llamamos rayola, y otro de ladrillo delgado, ambos colocados con yeso. Se exceptúan las plantas del primer piso que serán dobladas con cemento. Aquí empiezan los inventos de Guastavino. Seguramente pone cemento en la planta primera porque allí hay las máquinas, las cardas, los batanes que sirven para, que son máquinas pesadas y por tanto el cemento, él refuerza la bóveda con cemento ya claramente, ¿sí? Y esta es la planta de la hilandería cuando se vació la fábrica en 1908, ¿sí? En la que vemos 5 naves, ¿no? Con estas bóvedas, con esta solución. Por este lado hay poca invención, pero la hilandería funciona que el acceso de los operarios es por estas dos torres con esta escalera que se arranca en sentido horario y en sentido antihorario, y aquí lo verá Tim. Esta es la mejor escalera que construye Guastavino en España, como mínimo, ¿no? Porque es una escalera para los operarios, que es una escalera apechinada en el sentido en que realiza un acorde no solo de que la bóveda no hace el descansillo, sino que además veréis aquí la concordancia con las ventanas, porque los derrames y el capialzado de cada ventana coincide con el radio de curvatura de cada una de los tramos de bóveda. Estas escaleras están aún allí, ahora han puesto unos ascensores panorámicos en medio, pero bueno, están. Por tanto, las bóvedas de la hilandería aportan poco, algunas novedades en el uso del cemento. Segunda aportación de la fábrica es que la fábrica tiene color. Por eso he utilizado esta pintura de época en la que el cromatismo es importante. Esta es la fachada de la hilandería. El contrato dice, las fachadas se construirán de mampostería mixta, o sea, de mampostería ordinaria en el interior y medio sillarejo en el exterior, pero las jambas y arcos de las ventanas, cuerpos, puertas en general y los ángulos serán de ladrillo. Y en cambio, los otros edificios, los de departamentos y cuartos de máquinas, se construirán de mampostería concertada. Si os fijáis aquí, estos son sillarejos, ¿sí? Y aquí es mampostería concertada. Por tanto, hay todo un trabajo sobre el carácter de cada uno de los edificios, sobre su función, cómo se expresa al exterior Y el que tiene claro Guastavino es que el edificio alto es la imagen de la empresa. ¿Sí? El contrato continúa. Las fachadas solo serán repasadas, escardalladas con mortero, rellenando los vacíos e imperfectos de la mampostería, pero las jambas y arcos de puertas, ventanas, ángulos, fajas y cornices del edificio quedarán sin revocar. Este es el mensaje. Sin revoco en el exterior, ¿eh? Dándoles un color para igualarlos, indicando después las llagas y tendeles. Era muy habitual pintar con lechada rojiza la obra vista en aquel momento. ¿De dónde viene esto? Seguramente podía haber visto la prisión de Mataró de Elias Rogent, que ya en el año 52, pero una obra que no se termina en el 63, utiliza una fachada de obra vista. Fijaos que aquí está intercambiado, las jambas son de piedra labrada, y en cambio la parte trasera de la prisión, la zona de panóptico, tiene esta mampostería concertada. Si yo miro los trabajos de la Escuela de Maestros de Obras, todos los trabajos de arquitectura industrial están revocados. Las reválidas hasta el 68. Si yo miro algún trabajo de alguna reválida, por ejemplo, casa para un abogado, pero suponiéndolo en Mataró, pues resulta que al estar en una localidad pequeña, la fachada exterior sí que es academicista, pero la interior sí que tiene este acabado, que es el que pondrá de moda Guastavino. Si yo comparo las fábricas, el vapor Bell de Sants es neoclásico revocado. El ladrillo está, la fábrica de ladrillo está, pero está revocada. Esta es la tradición. Lo que hace Guastavino es otra cosa. Es una atención a la policromía, tal como en los debates europeos estaba continuamente estas cosas en los años 60. Y por tanto no nos debe extrañar. Si él en el año 75 construye la fábrica Muntadas Aparicio y Cía, que tuvo la desgracia que estaba en el planeamiento en medio de la Gran Vía de Barcelona, pues cuando se abrió la Gran Vía se tiró, pero fijaos que la fábrica esta tiene los mismos aparejos, los mismos acabados exteriores. ¿Cuál es el impacto de esta decisión? Pues que buena parte de la arquitectura industrial catalana posterior tiene estos acabados. Esto es la colonia Borgoñá, que es la colonia de los ingleses, porque es la Coats, en la que eran capital escocés, ¿no? Fijaos esta fábrica, el acabado, ¿no? Es exactamente este, con las mismas fajas. Después, un arquitecto culto como Camilo Oliveras, cuando construye la Casa de la Maternidad y de Expósitos de Barcelona, buen lector de Violet, hace una interpretación mucho más culta de este trabajo, ¿no? De mampostería, esta idea de Violet, ¿no? ¿Cuál es el mejor material para cada momento? El mejor dintel es de hierro, la mejor ménsula es de piedra, luego continuamos con algo más blando, que es el ladrillo, los paños se hacen de mampostería, ¿no? Ahora encuentro un arco, el arco vuelve a ser de ladrillo, ¿no? Esta sinceridad constructiva, ¿no? Es lo que está marcando el camino de la fábrica Batlló, ¿sí? Que nos lleva hasta el año 1906, Can Trinchet, en Hospitalet de Llobregat, el mismo planteamiento de fachadas. Y vamos a la estrella, ¿no? Que es que Guastavino, en la sala de telares de la fábrica Batlló, escoge enterrar la fábrica y construir unas bóvedas vaídas sostenidas por columnas de hierro colado con unas claraboyas. Unos 113 metros por 80 metros, una sala grandiosa como se ve en esta foto, ¿no? Con todos los telares, imagínate el ruido que hacía esto. Claro, yo me pregunto, ¿de dónde sale esto? La tradición inglesa, desde el año 53 como mínimo, por ejemplo, en Salts Mill ya hay la planta baja de los telares con diente de sierra. Y rápidamente el diente de sierra se incorpora en Barcelona en la España industrial, lo que se llama el vapor nou de Sants, ¿no? Que, si os fijáis, ¿no? Ya tiene en planta baja y tiene la cubierta de diente de sierra. Este no es el camino. El camino es otro edificio que está en Leeds, construido por Joseph Bonamy the Younger y James Combe, que se llama Temple Works. Este edificio tiene una sola planta, con bóvedas, no son vaídas, son bóvedas de arista, con claraboyas, sostenidas sobre columnas de hierro colado. Y en los textos de la época que podía haber leído perfectamente alguien cercano a Guastavino o a los hermanos Batlló, escribía, James Combe escribía: las ventajas de esta configuración son la facilidad de control, la facilidad de acceso de las máquinas, la capacidad de mantener la uniformidad de temperatura y humedad, importantísimo para los telares, la ausencia de corrientes de aire, la simplicidad del engranaje motriz y la excelente ventilación que es tan deseable para la salud de los trabajadores. Y este edificio, terminado en 1840, tiene que ser, de alguna manera, con estas claraboyas cónicas que cubren, de cristal, que cubren cada uno de estos elementos, ¿no? Tiene que ser la base de nuestro edificio, ¿sí? Esto es Temple's Work y esto es Guastavino. Por tanto, continuamente yo os propongo una mirada de transferencia tecnológica inglesa a Barcelona, porque ya desde Collins ya sabemos que hay una transferencia desde Europa a Estados Unidos, ¿sí? Lo que pasa es que esta transferencia tiene más recorridos, ¿eh? ¿Cómo construye esta sala? Pues columnas de hierro colado, unos arcos, una bóveda vaída, una claraboya, y por la parte superior lo rellena de cascotes, las bóvedas se rellenan de cascotes y construye una solera ondulada de ladrillo, seguramente con un par de capas de rasilla, ¿sí? Que hacen este mar, ¿no? Que en teoría desaguan los extremos. No hay otra solución porque no podemos desaguar, como es tradicional, por el interior de la columna de hierro colado, el bajante, porque estamos bajo cota de alcantarillas, digamos, ya estamos 3 metros por debajo del nivel de la calle. Por lo tanto, tenemos que desaguar arriba de alguna manera, ¿no? Esta es la estructura más interesante, la experimentación más potente que realiza Guastavino en esta fábrica. Este es un dibujo de un estudiante nuestro en el que intenta, a través del contrato, explicar cómo debía haberse montado. Los despieces de ladrillo quizás son un poco diferentes, pero sería un poco esta imagen. Naturalmente, también está atirantada todas las bóvedas porque hay muchas vibraciones, porque los ejes horizontales, al que diem els embarrats, ¿no? Están unidos a las columnas y necesita una estructura muy rígida para sostener toda la vibración que hay en esta sala. ¿Qué decía el contrato? Las bóvedas serán tabicadas, empezando por un grueso de baldosa común unida con yeso y luego 3 gruesos de ladrillo delgado que lo sean de cemento. Cemento porque necesita impermeabilidad. Alternativamente, en cada centro de bóveda habrá unas lucernas. La bóveda tiene un grueso de 12 centímetros. 3,50 por 5,32. No está mal. Esta es una foto de las obras que se están realizando ahora, en la que se ha descubierto una de las bóvedas que está con el edificio que se le puso encima, ¿no? Y respecto al edificio, el dibujo que hicimos, ves que hay dos fajas de refuerzo que nosotros no habíamos dibujado en su momento. Esto es la claraboya que se cerró. ¿Cuál es el impacto de Rafael Guastavino por lo que respecta a la nave con bóvedas vaídas? Esto es Poblenou. Mirad. Todo son bóvedas. Bueno, no tiene mérito porque estas 3 manzanas son las de Joan Torres Guardiola y por tanto se construyen con una misma mentalidad, ¿no? Pero ya se ve que hay otros ejemplos, ¿no? Voy a repasar algunos para que veáis que las imitaciones son absolutamente calcadas, ¿no? La fábrica Recolons, construida muy poco después, 2 años después de la inauguración de la fábrica Batlló, es una fábrica que curiosamente dispone la nave en planta baja para colocar las máquinas de hilar, no los telares, es esta nave y está cubierta, ya lo veis, de la misma manera. O la fábrica La Bauma en Castellbell y Vilá, 1896, vuelve a ser lo mismo. O las especulaciones que realiza Joan Torras, mezclando la estructura metálica, ¿no?, con con el cordón superior parabólico para recibir la bóveda vaída por encima, ¿no?, para crear una concordancia, ¿no?, estructural. O una empresa pequeña de las Corts, la Saída, que veis, trabaja con esto con toda normalidad en el año 1900. O la Chamón y Triana, que es una fábrica de contadores de gas, que ahora se ha perdido porque está el lugar donde hay piscinas y deportes, que construye un arquitecto como Villar y Carmona en el año 10. Lo mismo. Bueno, digamos, las claraboyas cambian de posición porque son bóvedas más grandes, son de 8x16 estas bóvedas. O el carburo de San Adrià de Besòs, 1918, con una mezcla también otra vez de estructura metálica con el cordón superior curvado para recibir la bóveda vaída. Y quizás la última, 1925, la fábrica Bagaria de Cornellà de Llobregat de Montesfeu Estrada. Por tanto, el impacto de la fábrica es brutal. Es decir, la escuela de arquitectura llevaba a sus estudiantes a ver la escalera, a ver las fábricas, no sé, Benito Pérez Galdós, ahora no me acuerdo de la novela, hay un momento que hay una visita a esta fábrica en medio de la novela de una pareja de recién casados, no sé si es Fortunata y Jacinta o una de estas. Para terminar, porque ya sé que vamos tarde. ¿Cómo está esta fábrica hoy? Esta fábrica tuvo una suerte y en parte una desgracia. La fábrica funcionó muy poco tiempo porque los atentados anarquistas hicieron que los Batlló y Batlló cerraran muy rápidamente la fábrica. Lo que pasa es que eran familia bien conectada y vendieron todo el conjunto a la Diputación de Barcelona para crear una universidad industrial, que es lo que se llama la Escuela Industrial. Por tanto, con mucha facilidad se convirtió la hilandería en una universidad, se convirtieron la sala inferior en unos laboratorios hasta que faltó espacio. Esto faltó espacio en 1926, en la que se encarga a un alumno de Gaudí que se llama Joan Rubió i Bellver que amplíe muchos metros la escuela. Y él, atento a Guastavino y con un poco de dolor en el alma, lo que hace es lo siguiente: colocar esta espina de edificios aquí encima, que es esta que veis aquí, con una nueva fachada, y lo que hace es elimina la primera crujía de bóvedas de la sala para crear un patio inglés y iluminar lateralmente, elimina 2 tiras de bóveda para introducir las escaleras a la planta inferior y hace coincidir toda la modulación del edificio a las bóvedas del edificio anterior. Casi igual que Hernán Ruiz del Viejo en la mezquita de Córdoba. Entonces, ¿qué pasa? Que ahora si os vais a pasear allí, no vais a ver el mar de bóvedas, pero si podéis entrar debajo, os vais a encontrar que las bóvedas siguen estando con partes reforzadas porque hay un edificio que ha dejado los pilares embebidos dentro, ¿no? Pero es posible, ¿no?, recorrer estos espacios viendo este ejercicio inicial de un Guastavino muy joven, pero con gran capacidad, como veis. Rubió hizo otra cosa. Respetando y entendiendo lo que había hecho Guastavino, el nuevo edificio tiene casi el mismo aparejo. Lo que pasa es que la mampostería ordinaria lleva lo que llamamos en Cataluña una encintat, una cinta que imita un hexágono que lo identifica para que se vea que esto es 1926 y no 1868, pero la apariencia, las fajas con dentados, esta simulación de dentículos, etcétera, está hecha con toda la intención para integrar el edificio y, cómo no, una escuela industrial se parezca a una industria. Bien, no les voy a cansar más. Muchas gracias y les agradezco su atención.
Bueno, vamos a hacer un turno de preguntas. ¿Alguna pregunta que tengáis? Tenemos pocos minutos, pero los aprovechamos. Seguida paso la palabra si alguien quiere hacer una pregunta. Tenemos un micrófono. Y si no, yo arranco porque yo tengo muchas cosas que comentar, pero prefiero que arranquéis vosotros. Una pregunta por allí. Luis, parece que eres Luis, ¿no?
Buenas tardes. La mía era una pregunta para Derek. La formulo primero en español y después, si no entienden, en inglés.
Derek, can you sit here? Yeah.
Did you make any study for the dampness, for condensations? Sí, le he preguntado si hicieron algún estudio de condensaciones.
No. Have you understood? If you study some damp studies about condensation, steam condensation.
We have not. We did do when we did the grouting of the vault at St. John the Divine, we used a condensation. We used steam to pre-wet the masonry, which is not really what was asked, but was an interesting application of infusion of moisture into that space prior to the grouting. But we have not looked at moisture within those structures.
Mm-hmm. Más preguntas. Yo tengo una para Ramón sobre la chimenea. ¿Cuántas chimeneas hay de 62 metros de altura en Barcelona? O sea, ¿por qué una chimenea tan alta? Y la base de la chimenea tengo entendido de que es un hiperboloide. ¿Eso es así?
A ver, yo la forma exacta no te la puedo decir porque no he hecho la comprobación por si es un hiperboloide o no. Es decir, lo que él hace es, es una chimenea octogonal que a partir de un momento se va ensanchando y va ensanchando casi asintóticamente. Esto es un hiperboloide, ya lo tendríamos que comprobar. A ver, tiene 63 metros porque es una fábrica que tiene 4 máquinas de vapor para la helandería y 4 o 6 máquinas de vapor para la sala de tejer. Y solo hay una chimenea. Entonces, lo que se hace es que las máquinas de vapor están colocadas cerca de las salas porque las transmisiones hay un riesgo de perder potencia, pero el humo de las calderas va por túneles subterráneos hasta la base de esta chimenea. Y por tanto necesitamos una chimenea que tire mucho, porque debe tirar para recorridos de humo en horizontal pues de 50 metros. Y funcionaba.
Pero no hay muchas chimeneas de este tamaño, ¿no?
No.
Es que yo no conocía una tan grande.
No, tan grande hay una de hormigón armado que hizo Peñabef en Sant Just Desvern, más tarde, pero,
sí, no,
pero en ladrillo no.
Uh-huh.
Pero es que hay esta complejidad de que tienes que trasladar. Hay la voluntad de que haya solo una chimenea, podría haber dos.
Ya.
Él decide que haya una.
¿Y quién hace de puente con Inglaterra? ¿Se sabe?
No está estudiado esto. Pero el puente normalmente son los industriales. Los que están viajando son los representantes de la empresa Batlló, de la empresa de Güell, ¿no? Güell tiene los contactos porque es que de Inglaterra vienen las máquinas. Es decir, todas las máquinas, todos los telares, todas las self-actings vienen de Inglaterra. Las máquinas de vapor venían de Inglaterra, primero de contrabando, es decir, se compraba, o enviabas un representante a Inglaterra, allí negociaba la compra de la máquina. La máquina se desmontaba, se enviaba por partes en 3 barcos, se recibía en Barcelona y contratabas técnicos ingleses en Barcelona que sabían montar la máquina de vapor.
Porque había aranceles o algo así. ¿O qué?
No, porque las primeras máquinas eran solo para los ingleses.
Ujú.
Y por tanto, la tradición allí es que siempre hay representantes en Inglaterra, sea por economía, para contratación y para saber lo que está pasando. Por tanto, es lo normal.
Ujú. Muy bien, muchas gracias. ¿Más preguntas? Go ahead.
Maybe it's for anybody or everybody who could answer. It was so enlightening. I didn't know the scale at which he was, functioning, the number of projects he was handling. My question is, like, once the vault is started, it was all built in one stretch, or was he like doing multiple projects at once? How did he manage to make 1,000 buildings just in one country? That's my question. And also, was all the bricks or the tiles handmade? Was he also involved in the making of the materials and preparation of the materials, or more like how he got it done?
I think Ken can answer that. Hmm? Oh.
No, no.
Oh,
Well,
Tim.
well, the tiles were not handmade. The bulk, most of the tiles were not handmade. And Derek, we know that, and Tim, we know that there's a patent for the extrusions. The tiles come out in a block, and you use the trowel to cut them into individual tochas. But so you could make a lot of those by extrusion. And the tiles that we worked with in the Pyrenees, 20 years ago, were made that way. You actually disassembled them on site in some cases. It's still a great question. The manufacturing facility, which we've all visited at one time or another, I mean, it's expansive. There's a lot of it there, but it seems like, well, obviously they got it done somehow or another. So, Derek, Tim, you got a comment?
Guastavino was working at a period in the U.S. where the building technology was evolving very rapidly, and one of fireproof construction, which is what he started in, was very important after several fires in major cities in the United States, and everybody got into the business of manufacturing or producing or building or all three: fireproof floors, fireproof constructions. Very early on, that was all based on ceramic tile. They used flat tile arches, and concrete then came in. There was brick. There was all kinds of crazy ideas that we run into in production and execution in New York City. So I think there was a moment where there was a lot of tile manufacturers, both decorative tile for terracotta, and then also the structural tile that was used for a whole host of reasons. I found recently, in looking at yet another dome at the Dime Savings Banks in Brooklyn, that the tile that was installed on the wall was imprinted with NATCO, National Tile Company. So I think that at some point or another, I don't know the date of that building, whether it must have preceded the Ceramica and Woburn, but there was just tile everywhere. And I think the folks who were fabricating that stuff were happy to build whatever it is that he wanted in terms of produce this, get it out the door as material that they could sell.
John Oxendorf did a study. They have production records some production records from the Woburn plant, and John kind of did a study. And I think what he was looking at was like, the amount of, he was looking at production of tile over time. But I don't know that he ever looked at whether that was enough tile to explain all the projects that were going on at that time. That would take a fair bit of work to estimate the volume of tile that you need for a given project, and determine whether those two things match up. Does production match up with the materials that were being produced? and that were required. I'm sorry, for the construction. And as Derek said, maybe they had no choice but to source tile from other companies. And I had never heard the NAFCO story. That's very interesting. Yeah. And then there are the decorative tiles, which are really a different story. I mean, the quantities are much smaller. And I don't know that we have records on that. I think it was mostly the production tile.
Yeah, I'd like to add that the other complexity that you need to keep in mind is when we saw that map of where in the US all these projects were, like they were so scattered. And so, this story of a father and son company, right? It was much more than that. They had offices in the Flatiron building at first, right? Fancy place to have your office. This was a big, it was a very well organized company who was able to translate its knowledge to different places, right? There's vaults like this in a McKim and White building at the American Academy in Rome, right? Like, how did they get that? Like, how did McKim and White get that knowledge? Maybe through the Guastavino company, I don't know. Like, even to Italy. So they had their mechanisms. I don't think they're very well studied, unless Derek knows about.
I don't have that, but this is the beginning of a conversation that Kent and I will have across the auditorium here for the next 3 hours. But Margaret's going to talk on Friday about some of our train station work, and I'm going to mention the work at the Buffalo Central Terminal. As we started that work, I had never looked at the factory order cards, which is what John had looked at for his study. And so I went and I looked at the factory order cards for that building, which has got some substantial amount of tiles. It's a stack that was like this, and there were duplicates, different colored cards. I think one went to the shop, one went to the accounting office, and so forth. And I thought, well, I don't have any time, but I'm going to go through and I'm going to take all the information on those cards and put it in a spreadsheet. And I thought that I could have a nice, concise spreadsheet that documented the different colors that were ordered and the different sizes of tiles that were ordered. The spreadsheet that I ended up fabricating was as big as this desk. I tried to print it out at the office once and it just kept running through the printer. It was kind of insane, but they had a process, and this was for acoustalith tile. So it was not tile that it was manufactured in a mass production kind of way, but not extruded and very complicated tiles that were very small to very large, and remarkable amount of work. It's something that's worth more study.
¿Más preguntas? Bueno, aquí hay muchos alumnos del máster y creo que habéis visto muy buenos ejemplos y os dais cuenta del nivel de profesional que tienen, digamos, en Estados Unidos, especialmente en Nueva York, ¿no? Digo, cuando van a estudiar un edificio, cómo se estudia en detalle, incluso en circunstancias difíciles, como le contaba Ken, ¿no? Digamos, colgados en una cuerda. Y de hecho, 2 alumnos del máster acabaron, uno trabajando con Ken y otro trabajando en el estudio de Tim. Ahora están en otro sitio, pero bueno. Yo quería preguntar también una cosa a José Luis respecto a los teatros. Me parece fascinante que establecieras ese contacto y que tuvieras lo has hecho tan sistemático, ¿no? Al final de ir buscando hasta encontrar realmente un poco la inspiración, y es, creo, bastante verosímil lo que estás explicando, porque son ejemplos que están ahí, sabemos que se movía. De hecho, creo... Alguien ha dicho, pero falta un edificio que han descubierto hace poco de Guastavino. O sea, hay un edificio en Sabadell que han encontrado de Guastavino que no estaba documentado. Quiero decir que
una noticia muy reciente, pero no es un teatro.
No es un teatro. There's a new building by Guastavino discovered in Sabadell very recently.
Sí, pero esto es de hace pocos días. Yo lo he visto, pero la verdad es que tampoco me ha interesado mucho. Porque llega un momento que vete tú a saber. No lo sé. No, pero a ver, yo ahora estaba muy interesado por los teatros, punto.
Sí.
Y ya he tenido suficiente.
No, lo que te voy a decir es que al final el radio de acción que uno piensa en Barcelona, o sea, llegaba más allá, o sea, pero que él tenía...
Sí, pero fíjate que Oliva, Benet Oliva, no ha encontrado ninguna referencia. Y Benet Oliva ha hecho una investigación sistemática de todo lo que son los centros de documentación, y etcétera, y de lo que son de derechos de la propiedad, etcétera. Y que haya uno en Sabadell, que no sé, yo no lo sé, es que no lo sé. Yo de momento soy un poco neutro, no lo sé.
Yo lo he visto y he hablado con el arquitecto y, digamos, es bastante verosímil. Es decir, que al
Bien,
final...
pues,
Y
chico,
digamos, él tiene documentación, lo que pasa es que no, digamos, todavía no está muy publicado, pero bueno, parece que es cierto. Bueno, si no hay ninguna pregunta más, bajamos abajo y nos relajamos con un aperitivo. Muchas gracias por vuestra atención, gracias por todo el esfuerzo de los ponentes. Mañana seguimos a las 9, pero en la Escuela de Arquitectura. Correcto, todo claro, dónde hacer en la sala de proyecciones de la Escuela de Arquitectura. Ahora aperitivo. Venga, adelante.
¿Qué, perdón?
Muy interesante lo de los teatros.
Sí.
Me gusta mucho, sí, sí.
Bueno, mira, pero porque...
Muy bien.
Es que esto no lo he dicho nunca a nadie, ¿eh?
No.
Ni nadie se lo ha preguntado. ¿Vale?
Sí, es verdad que eso es siempre la...
Oye,
sí.
ya parece que Guastavino hace un teatro.
Sí.
Y en un mes.
Ya.
Hombre. Y lleno de críos, con todo el verde que tenía. No me lo creo.
Ya.
No me lo creo.
Ya.
Y no me lo he creído hasta que ha salido.
Hasta que lo has encontrado.
Però, oye, 17,3.
Sí, curiós.
El normal és que fos de Reus, perquè tots els arquitectes són de Reus, que si els alguna cosa no l'ha pegat.
No, mira, aquest
Hay
era de
algunos que
Manresa.
no, però...
No, aquest sí, no, això sí, però que la cuna d'ell, sí o no, que vagin a veure què ha fet el de Reus, vull dir que és un moment la capital. Sí o no?
En aquell moment?
No, encara
no
no,
ho
perquè
sé.
de manera que Montanet...
A veure, el que és segur que era l'únic que s'estava construint en aquell moment.
Vale, per això.
Que vas amb el Mèrico.
Gràcies.